Okay. Hello everyone. So let's begin our today's question session. Okay. Today we will solve a lot of questions. But first we will revise yesterday's work. Okay. Okay. So we have done two set Venn diagram and three set Venn diagram. So we will go through a quick revision and we will see how the things unfold when we start the problems. Okay. So for the two set Venn diagram, what we have learned, let's go through that part first. Okay. In this, set A is there and set B is there. So A union B is equal to n of A plus n of B minus n of A intersection B. A union B is equal to n of A plus n of B minus n of A intersection B. I think so everyone is clear with this formula now. This part is known as A intersection B. This part is known as only A or A minus B or A intersection B dash. We have given this part three types of naming, or one more which we have learned yesterday only, n of A minus n of A intersection B. So the most important is the first one, because by that thing only we will get the exact value of that portion, only a portion. So let's write about only B. This is only B. So only B or n of B minus n of A intersection B, or B minus A or B intersection A dash. All these four things are for B and A. Yeah, sure. Okay, let's move on to three set Venn diagram. For three set Venn diagram, we learned three formulas. Set A is there, set B is there, set C is there. Correct? Set A, set B, set C. So let's go through all the formulas. First formula was N of A union B union C. This is read as at least one of A or B or C. At least one of A, B or C. Similarly, in the previous thing also, A union B can be read as at least one of A or B. At least one of A or B. Correct? So, this formula was, if you remember, we learned it in this way that we are keeping three discs on top of one another. Three discs on top of one another. Okay? So it will be A plus B plus C. So n of A plus n of B plus n of C. Now we said this part came twice. That is A intersection B came twice. So we removed it once. A intersection B. Similarly, B intersection C also came twice. So remove that one also. Now n of C intersection A. While removing these three parts, this central part is A intersection B intersection C, got removed three times. So we have to add it one time. N of A intersection B intersection C. Correct? So this was the formula for at least one of A, B or C. Next formula which we did was, exactly one of A, B or C. Okay. Exactly one means this yellow portion. This yellow portion is the exactly one part. So for that, what we have done, we have taken n of A plus n of B plus n of C. But this white portion has to be removed completely now. And this white portion is how many times? 2 times. So we will remove it completely. So 2 times A intersection B minus 2 times B intersection C minus 2 times C intersection A. So this central region got removed how many times? 6 times. So central region got removed 6 times, but it was only 3 times there. So to make it 0, we have to add 3 from our side. Okay. It was only 3 times there, but we have removed it 6 times. So we have to add it 3 times. So this is the formula for exactly 1. Now comes the formula for exactly 2. Uh, let's take this. This portion will be exactly 2. So third formula I'm writing here. Exactly 2 of A, B or C. Okay. From this portion, we have to remove the central portion. From this portion, we have to remove the central portion, and for the third part also. So n of A intersection B plus n of B intersection C plus n of C intersection A minus 3 times A intersection B intersection C minus 3 times A intersection B intersection C. So this was the total summary of our yesterday's class, what we have learned. Okay, if somebody missed that thing, they can just take a screenshot. We will move on to questions now. Is everyone clear up to this point? If anyone is having any doubt, we can discuss that. All are saying clear. Very good. Okay, nice, nice. Very good. Excellent. Okay, so let's move on to question now. Let's start with first question. Try it for a minute. I'm giving you a minute to solve it. A option, A option. Many of you got A option. So x and y are two sets such that x is given, y is given. So we will apply the formula, two set Venn diagram formula. So what was two set Venn diagram formula here? Let's see it. So n of x union y is equal to n of x plus n of y minus n of x intersection y. So here x union y is given as 38, x is given as 17, y is given as 13. So x intersection y. I will take it here, I will take this here. So n of x intersection y is equal to 17 plus 23 is 40 minus 38. So our answer is 2. Very good. Answer is 2. Everybody got this answer? Any doubt in this? Okay, excellent. So let's move on to next one. Try it, try it, try it for a minute. Sorry. Yeah, it's raining here today. option B, 5. Okay. So let's read this question first. If x and y are two sets such that x union y is given as 18 element. So number of element in x union y is equal to 18. So we have read up to here. X has 8 element. So number of element in x is equal to 8 and y has 15 element. Number of element in y is equal to 15. Then we have to find x intersection y, similar to previous question. So n of x union y is equal to n of x plus n of y minus n of n x intersection y. So this is equal to 18, this is 8, this is 15. We have to find this x intersection y. So this became 23. So n of x intersection y is equal to 23 minus 18, which is equal to 5. Excellent. Correct answer. Okay. So let's move on to next one. Let's move on to next one. Okay. If S and T are two sets such that S has 21 elements. S has 21 elements. Okay. So many of you are saying answer as A. Okay. Oh. F and S, sorry, S and T are has two sets such that S has 21 elements. So number of element in S is equal to 21. T has 32 element. Number of element in T is equal to 32. S intersection T. S intersection T is equal to 11 element. We have to find the union. So simple, S union T is equal to N of S plus N of T minus N of S intersection T. Okay. So N of S is 21, N of T is 32 minus 11, that is 53 minus 11, which is equal to 42. Very good. So answer is 42. Excellent job. Okay. So let's move on to next one. Try this one now. We are going with very basic question so that you can have a grip on the formulas. Again, A option. Many times A options are coming. X and Y are two sets such that X has 40 elements, X union Y has 60 elements. Okay. So let's write all the data. N of X is equal to 40. X union Y. X union Y has how many elements? 60. And N of X intersection Y is given as 10 elements. So number of element in Y we need to find. Okay. This is the all data given in this question. So we will apply the formula x union y is equal to n of x plus n of y minus n of x intersection y. So x union y is given as 60 here, n of x is given as 40 n of y is not given, x intersection y is 10, correct? So n of y came out to be 30. So option number A. Okay, nice. Everybody got this? So let's move on to next question. I think so here will be union, not E here. X union Y. Very easy question. No time to waste in this. X union Y is equal to n of x plus n of y minus n of x intersection y. So x union y is 50, n of x is 28, n of y is 32. We have to find the intersection part. So this became 60. So x intersection y is equal to 10. 60 minus 50 is equal to 10. Okay, let's move on to next one. Now comes the symmetric difference. If you remember the symmetric difference, correct? Oh, some people got the answer for this one also. Nice. Some are saying A, some are saying B. Dhanush is saying A. Okay. Chandika is saying A. Okay. Naman is saying A. So those who are saying A, that's wrong or correct. Let's see. Because half of the population is saying A, half of the population is saying B. Now C and D also came in picture. Okay, nice. So let's solve it by drawing Venn diagram. So this is set A, this is set B. Set A has 50 elements, set B has 20 elements. Okay. Now this common region had 10 elements. Common region had 10 elements. So A triangle B symmetric. This is equal to n of A minus B union n of B minus A. Basically, we have to add the numbers n of A union B plus B union A, let's say, because this is this given region here. This is A minus B, this is B minus A. So I have drawn this. Now tell me the correct answer. All of you should tell a correct answer now. Now also people are saying 70. How? Think of it. It's not 70. Okay. So let's see. Now, I will just explain this. So this whole was 50. This whole was 50. And this part got 10. So what we are left with here? Only 40. I told you this part is only A. Only A means n of A minus n of A intersection B. That is 50 minus 10 equal to 40. Now this part will be, whole part is 20, common part is 10. So this part will be also 10. So 40 plus 10 equal to 50. Okay. 40 plus 10 is equal to 50. Now everybody understood? Yes. So let's move on to next one. If A and B are two sets, that's a very easy one. You can do it. Very easy for you all. So we have to find A intersection B. So n of A union B is equal to n of A plus n of B minus n of A intersection B. Now we already know, given as A union B is given as 110, n of A is given as 70, n of B is given as 60. We have to find A intersection B. 130 minus 110, that is equal to 20. Very easy. Option number D. Correct. Very good. Very good. So I am thinking that this is very clear to everyone now. Nobody is having any doubt now. Okay. So two set Venn diagram, you are very thorough with now. You can solve any kind of question in this. Okay. So let's do this one. Now we will just changing some format here. Okay. In a class of 60 students. So we are given now universe value also here. So we are given here universe value. In a class of 60 students. So let's make a diagram here. So universe value is 60. Okay. 25 B, C, A, each and every option. Only D is left. Somebody please say D also. So everything will be covered. Most are saying A and B. Yeah, Money said D also. Very good, Money. In a class of 60 students, 25 play cricket. Okay. So cricket is played by 25 students and 20 students play tennis, and tennis is played by 20 students. 10 students play both of the games. Okay. So this region is 10. Everybody is understanding this thing? Then the number of students who played neither is. So we have to see what what number of students are playing neither cricket nor tennis. So for that we will find n of C union T. C union T. That is n of C plus n of T minus n of C intersection T. Now n of C is 25, n of T is 20, and their common part is 10. So we got this as 35. So we got this as 35. So total number of student in this region, this C union T means this part, this part, this part, all 3 point parts combined, which is equal to 35. So we have to find the students which are outside this region. So total was 60. So total was 60 minus 35. We got answer as 25. So these 25 are the students who are neither playing cricket nor playing tennis. Okay. So we can make many questions in this also. If I will ask you how many students are only playing cricket, only cricket. How many students are playing only cricket? Excellent, excellent, Jitesh, Ananya, Yash, very good. Many are saying now. Total was 25, the common was 10, so only cricket was 15. Now, what is the next question? Only tennis. Only tennis. Correct. Total was 20, only tennis will be equal to 10. Then if I ask you, then if I ask you C delta T, what is the value of C delta T? Tell me, C delta T. Excellent. C delta T is 25. So A minus B union B minus A, 15 plus 10 equal to 25. Okay. So let's move on to next one now. Can we? Yes. Okay. Similar kind of question to previous one. Mark it correct. Everybody please mark it correctly only. This is a similar kind of question in which universal value is given, that is 840%. 250 is not an option. Okay. 290, yeah, 290. Okay. So let's solve this. It's a similar kind of problem for you. So total universe is comprising of 840 people. 840 people. Okay. Out of these, 450 persons read Hindi. 450 persons read Hindi. Newspaper, I think so. They have missed the word newspaper. Or reads Hindi, English is also good. 300 reads English. 300 reads English. And 200 reads both. 200 reads both. Then same thing, we have to find a number of persons who are reading neither, nor Hindi nor English. So first we will find Hindi union English, that will be equal number of person reading Hindi plus number of person reading English minus number of person reading English and Hindi. Correct? So number of person reading Hindi is 450, English is 300, common is 200. That will come out to be 550. Okay, but we have to find number of person reading neither nor Hindi nor English. That will be equal to n of H union E complement, neither Hindi nor English. Yes. So n of U minus n of H union E. So that is 800 minus 550, 840. 840 minus 550, that is 290. Okay, 290. You are also saying the same thing. Option number B. That is 290. Very good, very good. Okay, so let's move on to next one. So I need to ask how many read only Hindi? Only Hindi? Exactly, exactly. 250. Now you all are understanding what is the meaning of only English, only Hindi, only A, only B. 250. And this will be equal to only English is 100. Okay. So let's move on to next one. Oh, nice. We can do this. Option A. So this is a very basic question, I think so. Only language. Language you have to understand in this. In a group of 100 students, know Hindi. Hindi is known by 100. English is known by 50. And 25 knows both. So we have to find total number of students because they are saying that every student know either Hindi or English. So n of H union E we have to find, that is 100 plus 50 minus 25, which is equal to 125. It's only a language based question, nothing extra in this. Okay. Simple formula. Here they want to say that universe, the outer thing, outer, after Hindi or English, there is no student. Outside there is no students. Are students who know either Hindi or English. There is no one who is not knowing both of the language. Yeah, very good, Varun. They are just trying to confuse by the language. Nothing else in this. Okay, let's do the next one. Minus 25 is very good doubt. After these many questions, if you are asking why we did minus 25, that's a good doubt. Matru, Gunayu, very interesting name also. In a survey of 600 students in a school, 150 students were found to be taking tea and 225 coffee, 100 were taking both tea and coffee. Now, just simple question only language you have to understand. In this era of social media, our attention span is very low, very low. So reading a two-line question is very hard task for us. So in a survey of 600 students in a school, I will draw the Venn diagram here. In a survey of 600 students, so total students are 600. Correct? Now they are saying that 150 students were found taking tea. Tea by 150 students and 225 were taking coffee. Coffee was taken by 225. 100 were taking both tea and coffee. 100 were taking both tea and coffee. So I will write 100 like this. Find how many students were taking neither tea nor coffee. So outside region again. Again, we will find tea union coffee, that is 150 plus 225 minus common part is 100. So 375 minus 100 is equal to 275. So what we have to find the outer region. Outer region will be N of T union coffee complement, that is universe minus N of T union coffee, that is 600 minus 275, that is equal to 325. So our option A is the correct one. Excellent job. Okay. So everybody is clear in this? Yeah. Jagati is saying that it's too easy only by seeing the question and we can answer directly. Yes, Jagati. So Jagati is our student who is, I every day see her message saying that, sir, I can't understand what, please repeat that again, sir, previous side, sir, next side, sir, I'm not understanding anything. But today she is saying that she's just by reading the question she can answer. That's a very good thing to hear. Okay. So very good. Keep that good work, everyone. Okay, let's move on to three set Venn diagram. Okay, let's move on to three set Venn diagram. Read the question properly. Take 2 minutes. Write it in your notes. Okay, I'm just giving 2 minutes to write the question because it's a lengthy question. We will not rush in this. Okay, I think so. Everybody has written the question. I will just explain this one. In a survey, it was found that 21 people like product A. So my habit is to draw a Venn diagram, or we can write the data also. So product A is liked by 21 people, correct? 26 like product B. 26 people like product B. And product C is liked by 29 people. Product C is liked by 29 people. So this much data is given. If 14 people like product A and B, I will write it here. That is A intersection B is equal to 14, they are saying. 12 people likes product C and A. C and A. C intersection A is 12. And 14 people like product B and C also. And 8 like all the products. So this is 8. Correct? Find how many like the product C only. Okay. Yesterday someone was asking this question only, that how to find only A, only B, only C in three set Venn diagram. So here there is no formula. We have to apply the diagram approach in this. Okay. So we have to find only C. Okay. So see this thing. This is B intersection C. This whole thing is B intersection C and its value is 14. If this whole was 14, so this region will be how much? 6. This region will be how much? 6. Correct. Now let's come to this part. This is C intersection A. This is C intersection A. This part. Whole is 12. This part is 8. So this part is 4. So this is 4 plus 8, 12. 12 plus 6, 14. Sorry, 12 plus 6, 18. So 29 minus 18 is equal to 11. So only C will be how much? 11. Okay. You know what will be my next question? My next question will be, what will be the value of only A here? What will be the value of only A here? Okay. So what we will do it here? A intersection B. A intersection B is given as 14. So 8 gone here, so 6 left here. So 6 plus 8, 14, 14 plus 4, 18. So how much is left here? 3. How much left here is 3. So you know what is my next question? So just tell me the answer for that. 6. You guys are becoming genius. Now we are connecting. We know what I want to ask, and you giving the correct answer also. I'm too happy today. So 6 plus 8 is 14. 14 plus 6 is 20. So left part is only 6. Okay. Okay. Nice. Let's move on to next one. Okay. Don't worry. Those who didn't got it, don't worry. We are having many questions like this. Okay. You will get it. Just take a screenshot. Move on. Okay. Now again, a language-based question. They are trying to confuse. What will be the answer for this? At least one of the two language. At least one of the two language means A union B. Okay, so I have written that. Made a more bracket here. This will be A union B. So let's say in a committee of 50 people speak French. So French union Spanish. So number of students speaking French plus Spanish minus French intersection Spanish. 50 plus 20 minus 10, that is equal to 60. Yeah. So at least one means union. On the first slide only we have written that thing. Okay. We were revising that. Okay, let's move on. Next one. Again a easy question. Yeah. What will the answer for this? C option 25. Very good. In a group of 65 people, 45 like chemistry. Group of 65 people, sorry, 40 likes cricket, not chemistry. 40 likes cricket, 10 likes both cricket and tennis. Okay, so 10 likes both cricket and tennis. How many likes tennis only? How to find this thing? In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? Okay. So they want to say this whole region is 65. Somebody is liking something. It's not written there, but somebody is liking something. Okay. So if this is 40, this is 10. So only cricket will be 30. So 30 plus 10 is how much? 40. So how many people are there? 65. So this will be 25. So only liking tennis will be 25. Easy question. Only we have to understand the language. In this question, they have not said us that each student is liking something. Okay, so we have to reduce from our own. Okay, let's move on to next one. Try this. Tell me the answer fast. C is chemistry, T is thermodynamics. Nice. Okay, D option 19. 19 people are getting. Okay, so again, coffee and tea, chemistry and thermodynamics. Coffee is 37, tea is 52. Yeah, group of 70 people. So everyone is liking something. So C union T is given as 70. Now let's apply the formula. 70 equal to 37 plus 52 minus n of C intersection T. That is 89. 89 minus 70 is equal to 19. Okay. Excellent. Excellent. You are giving answer faster than me. Okay. Neither question came again. So let's see. 225. Students are saying 225. And if you are saying that will be correct only. After these many questions, I think so nobody should get a wrong answer. In a survey of 400 students in a school, 100 were listed as taking apple juice. Okay. So 100 were taking apple juice out of 400. 150 were taking orange juice. Orange juice was taken by, let's say, 150. And 75 were taking both apple as well as orange juice. So A union B or A union O will be equal to 250 minus 75, that is 175. So from the universe we have to subtract 175, which will equal to 225. So see how much we are reducing the number of steps now. First question we did like 5, 6 lines, something like that. Second question, reduce, reduce, reduce. Now we got to one line only. Okay, let's move. Oh, this was the end. Okay, so three set Venn diagram. Today we did only two set Venn diagram and only one question of three set Venn diagrams. In the next class, we will be doing more of three set Venn diagram, and I will start a new topic as sets is completed for us. Okay, I will start a new topic for you all. uh, so our next topic we can take, let's say, Weaver method. Okay, and those who are having college can go to college. Obviously hostel guys will have to go. When is next exam? Okay, there is no information regarding next exam. Let's see. If it happens, it will happen on Saturday. It will be told to you. Yeah. So those who are going to hostel, enjoy your life, and we will enjoy here doing this bridge course. Yeah, next class, obviously. Tomorrow's class we will have good questions of JE only. Okay, all the basic things we have completed today in this lecture. So I have kept this lecture very light so that you can just get a grip of using the formulas. Okay. So next class we will be having only good questions. So let us take only 7 to 8 questions in an hour, and we will try to do much things in that only. Okay. So what to do, how to study, I will just give you a simple roadmap today because we are having time now. So I will just add a slide here. Okay. So see, I am just giving you a roadmap. Many of you are having doubt about how to study, what to study. So I will give you just a simple relation. From 2019, JE started giving. JE is having multiple exam, multiple set exams. Okay, like it started happening in shifts. So every year, every year from 2019, there are 20 shifts. 20 shifts means 20 into 25. That is 500 questions in JE main. I am saying in JE main. So from 2019 to 2024, 2019 to 2024, there were 30 questions, not 25 also. There were 30 questions. Okay. So let's take the lower value, 25 question. I am taking the lower value here, 25 question. So from 2019 to 2026, it's 8 year done. Minimum I am saying 8 years done from this format. So 500 into 8 is equal to how much? 4,000 questions minimum. Okay. Actual data is 5,200. Actual data is 5,200 because due to COVID region, there were not 20 shifts, there were 40 shifts and 45 shifts, something like that. In the 2020 year and 2021 also, there were many shifts and 25 question, 30 question. So actual data is around 5,000 question, 5,000 plus questions from only past 8 years. Okay. So you can imagine you have to, in mathematics, I'm just talking about, not physics, not chemistry, nothing. I'm just talking about mathematics. So you have 5,000 questions. Next year, you will not give the exam. So again, 500 questions will be added. So you have to solve these 5,500 questions, 5,500 questions, and you have to thoroughly remember these concepts. Okay, because these will be repeated again and again. So physics, chemistry, maths combined, it will be more than 16,500 question only in PYQ, previous year questions. Okay. So it looks like a very big task. It's look like a very big task to us because we have to complete sheets, and in sheets our exercise 3 is only based on this only. So what we have done, we have formed DPPs, daily practice problems. Okay. So we have taken all the good questions of these PYQs in that sheet only, so that you can complete all the PYQs with us only. Okay. So you will get all the sheets here. Okay, in the resonance material only, in which you will solve each and every question. Now this is all about PYQs only. Now let's talk about marks. So what you think, how much marks are required to get into an IIT, in IIT out of 360 marks? How many marks you need to get into IIT out of 360 marks? 275, 200, 300, 250, 200, 350. Okay, 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 okay. So that is just 95. J advance I am talking about. It's just 95 marks. And for qualifying it's just 74 marks. And you can say that I have qualified JEE advanced. PYQ is previous year questions. Okay, very, very random things. Okay, just don't waste our time. Let's talk about more interesting things. And what you think, how much to get into NIT in JEE mains out of 360? NIT or triple IT? Sorry, 300, not 360 here. It's 300 here. Triple ITs. What do you think? How much to get in 300? It's just 130 marks. 130 marks. Okay. So these are very, very doable things. You just have to be consistent for 2 years. Okay. Yeah, it's for open category only. You have to be consistent. For let's say somebody asking for IIT Bombay or IIT Madras, you need around 160 marks. You will get into any top of the 5 IITs. Okay, 160 plus marks in advance. Okay, let's say you are talking about NIT Warangal. So you will get around 160 marks in JEE mains. Okay, understood? So these thing we have to see. Triple IT is in Hyderabad, yeah. If you are not knowing triple IT is in Hyderabad, then very sad to hear you are preparing for this exam. Okay. So please be focused. Be focused. Our plan is to complete all these PYQs and resonance DPPs plus module, or you can say sheet. In this sheet only you will get all the PYQs. If you are able to complete it and revise it, for sure you will get into a good IIT or NIT, for sure. And qualifying marks for advance is around 80 out of 300. If you get 80 out of 300, you will be able to write IIT exam advanced. Okay. So that's the time for today. Next class, we will discuss a bit more about this. I think there is a good amount of knowledge you are missing in. Okay. You have taken knowledge from something here and there. You all are not knowing the actual data, but it's not an issue. Okay. I will try to enlighten you as much as I can, and I will try to motivate you to study hard. Okay, because a good start will lead to a better path. Yeah, I will try to explain as much as I can. Okay. No, nothing, Ananya. No additional coaching is needed. Only resonance material, resonance culture, you have to adapt it, and everything will be provided here. Why to waste money here there when you will get everything? All good teachers are here. Why to go outside? Yeah, it's kind of same, Naman. Like 90% of the syllabus is same. Okay, we will talk about it, all the other doubts. Please keep your doubts with you. Tomorrow's last 10 minutes, we will discuss all the doubts which you are having. Okay, keep your doubts, but keep it actual doubts so that you can get benefit from that. Okay, okay. Chalo, bye everyone. Take care.
Good morning, guys. Good morning to all of you. Today is really a good morning, good weather after so many days. Usually in Hyderabad, we don't have this type of hot weather session. This time I heard after a long time that we're having so hot days. Anyways, today is a very pleasant morning. And it's nice that we are enjoying the class from the comfort of our home. Let's continue. Yeah, it's raining. Yes, 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 yes. It's raining. It's cloudy. It's cool. Very nice breeze outside. Morning, everybody. Yesterday, I had discussed Newton's three laws. We went through the statement of first, second, and the third. And the third law was under discussion. And today, I'll be starting from the discussion on third law. Kalyani, I am from Chola campus, beta. I am in Chola campus in Madhapur. So, and this class is also telecast from this Chola center. We are having this online class studio in Madhapur. Here I am. So let's continue with the Newton's third law. I told you that this is one of the most famous, most popular physics laws, which even non-physics people also know this. For every action, there is an equal and opposite reaction. So this explanation or this statement makes the idea of Newton's third law very easy. But on the cost of making it easy, there is another aspect that it can lead to some uh, wrong type of interpretation. So just let's try to see that how to think about this Newton's third law. First of all, I'll suggest that when you think about the Newton's third law, what statement should flash in our mind? The third law says that if one body exerts some force on another body, then that another body will also exert the equal force in the opposite direction on the first body. Okay, so this is the precise statement of Newton's third law. From third law, what we come to know is that it is not possible that one body exerts a force on other and another body does not exerts a force on the first. So let's take few examples. If suppose this is a smooth horizontal surface, here you have a block A and then you have a block B. Now you are exerting a force and you see that both of them are accelerating towards right. This situation we discussed yesterday also when I was explaining you the idea of system. So here, uh, once again, if you look at it, the B is accelerating because of the force provided by A. All right. So if I show the forces on A, this is the force exerted by some external agent. And now since B is also accelerating, I will say B can accelerate because of a force exerted by A on B. I'm calling this force as FAB. FAB means force exerted by A on B. So now if A is exerting a force of FAB on the B, then from Newton's third law, B will also exert a force on A. I'm calling it FBA, force exerted by B on A. So as per the Newton's law, the magnitude of these two forces is equal. When I say magnitude, I mean that if suppose this FAB is 10 Newton, then BA will also be 10. So their magnitudes are equal and you can see the directions are opposite. If the directions are opposite, then we prefer to put a minus sign. See, force is a vector and a vector has directions, right? So if you consider one direction as positive, then negative means the opposite direction. So when we think from the vector's point of view, when you talk about any vector quantity, be very clear that plus and minus are indicative of directions only. They don't tell you this is something big or something small. In maths, when you learn something on the number line, there we see that the negative numbers are smaller, positive numbers are bigger. That's how we proceed there. But when you talk about vectors, you don't follow that pattern. For example, here if I say if one force is 10 Newton, another force is minus 10 Newton. So should I say minus 10 is smaller than plus 10 because it is minus? No. Since force is a vector, plus and minus only show the opposite direction. They do not tell you anything about the magnitude. The sign does not tell. But don't get confused. Suppose if I speak about the potential energy of a body, if I speak about the potential energy of a body, if I say the potential energy of body 1 is plus 10 and the potential energy of body 2 is minus 10, this time, yes, I will say the potential energy of 1 is bigger than the second. Why? Because the second one is negative, the first one is positive. Now, this time we are comparing in that sense what we understood or what we learned from the number line pattern, that the negative numbers are smaller there. So when you compare the scalars, when you talk about the potential energy, then yes, plus minus have the significance to make them bigger or smaller. But when it comes to vectors, plus and minus only show opposite direction. So this aspect, all of us have to be clear. And sorry, we will see that in these coming 2 years, the plus and minus sign are going to be interpreted in many different ways. Right now, I have given you an example in which there were two interpretations. For the force, if it was plus minus, we saw it only shows the change in the direction. If plus is one direction, minus is other direction. So that was the only significance of this plus and minus sign. If I speak about the potential energy, then plus minus helps me to make a comparison. Plus 10 is bigger than minus 10. If I take one more example of, let us say, charges, we say that electron is negatively charged and proton is positively charged. So again, this minus plus sign comes. So now in this situation, how to interpret what is the significance of a plus and minus? So in this situation, again, the pattern is different from these two. Whatever I spoke for force, whatever I force for energy, I will not speak the same thing when I speak about the charges, although the sign are the same, plus and minus. In charges, frankly speaking, plus and minus mean nothing. They don't mean anything. They only mean that charges are of two types. Okay, from the beginning of the development of physics, whenever the people realized that charges are of two types, so somebody started calling positive and negative charges. So they were just like labels. You understand what I mean by the word label? You can label anything as anything. I have a chair here. If suppose I'm very much fond of this chair, I can give a name to it, isn't it? I can say this chair would be called as Mount Everest. So that's just my wish. I give it a name, Mount Everest. No logic needed for that. I decide, I follow that. Same way, electron and proton, if they are called negative and positive, these signs are just labels. If it would have been taken in the opposite way, if the earlier people would have decided that no, let us take electron as positive and proton as negative, no change would have occurred. So here, when we talk about the charges, the plus and minus only shows a distinction of the types of charges that exist in nature. So lucky thing that only there are two types of charges found. If suppose three types of charges were available in the nature, then I'm sure plus minus sign would not have been used. Then we would have taken some different type of nomenclature. This is charge A type, charge B type, charge of C type, something like that. So coming back, the idea is that plus and minus have to be interpreted in different ways in different situations. So, whenever a new situation comes, whatever is being told to us, we are supposed to remember that precisely. Okay. So FEA and FAB. Coming back to these forces, we were pushing the block A, he was pushing the block B, both of them accelerating together on the right side. Now in this process, A was pushing B with the force of FAB and B pushed back the block A with force FBA. Now, as per Newton's third law only, I can say these two must be equal and opposite. So these are the action and the reaction pair. Okay, so this is one example of action reaction pair. Let us take a couple of more. If I say this is the earth and here is a person standing on the earth. So the earth is attracting the man downwards because of the force of gravity. So if I say the man experiences a force of gravity from Newton's third law, earth should also experience equal and opposite force in the upward direction. So now see this action and this reaction, they are again equal and opposite. If earth exerts a force on me, the earth will also experience a force from me. So I am exerted by a force and I become an agent who delivers the force, and these two have to be equal. Okay. So this is again one more example of action and reaction. Uh, Now, let's summarize what things we should keep in mind while we discuss this Newton's third law. So, I'll be writing them. See, these are very crucial points. That's why I would like that all of us are clear on them and keep it in your minds for the later references. Third law, number one, what's the statement? If one body exerts some force on other body, the other body will also exert equal and opposite force on the first body. So for these two forces only, we use this term of action and reaction. When I say when one body exerts some force on the other body, so if this force I am treating like action, then I say the other body will also exert equal and opposite force. So this force is now the reaction. Got it? So be clear, action and reaction are forces. You cannot generalize them and you cannot be philosophical while you talk about it. The problem with the Newton's third law is that it is taken into the philosophical and the social realm. What does it mean? A very common thing that if suppose somebody slaps somebody, he's angry and he just puts a slap on somebody, and then what happens? He gets a slaps back, right? So if one person is hitting somebody, he gets it back, and then we say, oh, it's Newton's third law, action and reaction. This would not be fair to do. Let's all be clear. Let's not bring the Newton's third law into our behavioral aspect. Maybe suppose I slap somebody and after being slapped, that person gets so angry and suppose he is damn powerful. He starts hitting me one slap, two slap, three slap, four slap, 10 slaps. Isn't it possible that if I give one slap, I get 10 slaps back? So would action and reaction be equal there? Of course not. It depends upon that other person, what mood he is in, what he is going to do. So, my point is that let's not correlate a scientific situation with a social or a behavioral aspect. Just to have the first initial example, it's fine. If we just think in a way, maybe whatever you do, you'll get it back. So, on a broader context, okay, you may sometime go with these such statements, but when you are doing a proper analysis of a situation, let's be very precise At that time, our understanding should be very comprehensive and precise. Okay. So now what are those points? Listen, this is the statement. These are action and reaction. Now about the Newton's third law or about an action and reaction, what are the crucial points to keep in mind? Number one, action and reaction never act on the same body. Action and reaction never act on the same body. If you remember that diagram which I made, this one, see, if I say this is action and this is reaction, you can see action was acting on B and reaction was acting on A. So both of them were not acting on the same body. So the first thing to remember is that action and reaction never act on the same body. Number two, action and reaction will never cancel each other. Action and reaction will never cancel each other. What do I mean by cancelling? See, if this is a block, if I exert a force of 10 Newton, it is me. Now, suppose you also start exerting the same force of 10 Newton on the same body in the opposite direction. Now, I can say that you are cancelling my force on the block. Okay. Why? Because I was exerting by a force on the right side, and now you start exerting by the same magnitude of the force in the opposite direction. So I'll say you are cancelling my force. So when we say cancel, that actually means two equal opposite forces acting on each other, and as a resultant, it becomes zero. Okay. So be clear, action and reaction will never do so. These two forces, since they are acting on the same body, it is never possible that this is action and this is reaction. That's not possible. Okay. Even if I don't tell you the story that I exerted 10 Newton, you exerted 10 Newton, I simply if show you this drawing. If I show you this drawing and if I ask, can these two 10 Newton forces be action and reaction? You should immediately answer no. Why? Because action reaction never act on the same body, and that's why they will never cancel each other. To cancel a force, you have to exert the force on the same body, isn't it? If I'm exerting 10 Newton on this block and you exert your 10 Newton on some other block, so will that cancel my force? No. To cancel my force, you have to exert the same force on the same body. And since action reaction don't act on the same body, that's why they will never cancel each other. All right. Third point, which is very crucial, action and reaction are indistinguishable. Action and reaction are indistinguishable. That means you actually cannot say that this is action and this is reaction. Let's go back to our this situation. I said this is action and this is reaction, but there was no reason why I called this as the action and that as the reaction. I could have very well said that this is action and this is reaction. And this is the point where our scientific idea becomes different from the social idea. That example of hitting, I was saying, if somebody slaps and he gets a slap back. So, doesn't this happen that when you were young, suppose, and you were in some fights with your some siblings, cousins, brother, sister, whatever friends, If some fights happen and now some elder people will come to intervene, why did the fight happen? If you remember, we would use the first statement for our excuses that I did not hit first. मैंने पहले नहीं मारा. And that becomes a very strong statement. I did not initiate, I only responded. So now in this situation, action reaction makes a difference. Yes, it matters also. Of course, I can say I was not the one who hit first. I was first hit and then I acted back. So in this situation, yes, there is an action which comes first and then there is a reaction which comes later. So in our social or general situation, action comes first and reaction comes later. This doesn't happen with the Newton's third law, action and reaction. Action and reaction are two forces which start acting simultaneously and stop acting simultaneously. That means action and reaction will appear simultaneously and disappear simultaneously. You cannot say that this was the first one. पहले इसने धक्का मारा फिर उसने धक्का मारा. This type of statement doesn't matter. Here also, you can't say that B pushed A because A pushed B. Actually, the moment A started pushing B, immediately at the same instant, B would also have started pushing A back. There was no time lag. There was no time interval involved. Okay, first B experiences a force. Now he is sustaining. Okay, are you pushing me? Now let me show what I can do. Now I will also push you. This thing doesn't happen. The moment A is exerting the force on B, at the very same instant, B will also start exerting the force on A. So there is nobody who is coming first or somebody who is coming later. And that's why this phrase of action and reaction that becomes meaningless here, that who came first or who came second. Let's take one more example. I think maybe it helps to make the idea clear. Action and reaction are indistinguishable. I hope all of us know that like charges repel and unlike charges attract each other. Am I right? If you have two protons close to each other, they will repel each other. If you are having one proton and one electron, they'll attract each other. Right? So I hope we are aware of this behavior of electrostatic force. Now imagine that I was having two protons in my hands and my hands were very far off initially. And now I bring those protons close together. So suppose this is the first time when you see two protons are kept close to each other. Okay. Now, because of their charges, this proton will repel this one and this proton will repel this one. When I say repel, that means the force exerted in such a way which will have a tendency to increase the separation. So from this proton, the force on right side one will be in this direction, and by this proton, the force on this proton will be in this direction. So this is one force and this is another force, and yes, they are again action reaction pair. The force exerted by this P on this P, if I call it action, then the force by this P on this P, I'll call as the reaction. But now I would like you to think, can I speak the other way around? Can't I say that this is action and this is reaction? Or just let me know, isn't it the same thing? Action, reaction. You can call anyone as action, you can call anyone as reaction also. Okay, so let's be clear, action and reaction are indistinguishable. One more point, they uh, stay in action for equal amount of time. When I say they stay in action, that means the exertion of the force. If suppose one body exerts a force on the another body for 10 seconds, So I'm saying that second body will also exert equal opposite force for the same 10 seconds. So the duration for which also the action and reaction are acting, they are coming into action, even that time is also equal for all of them. Okay, so yes, for Newton's third law, these are the things which we should always keep in mind while doing the questions, while analyzing any given practical situation. You have to keep this thing in mind. Action and reaction never act on the same body. Action reaction will never cancel each other. Action reaction are indistinguishable. They stay in action for equal amount of time. Okay, and although they are equal and opposite, but still for extra safety I'm writing a fifth point. They for equal amount of time, yeah, action and reaction can never be unequal. Okay, you can certainly say the fifth point is useless. When Newton's third law say that action and reaction are equal, then why I am saying the opposite statement that they won't be unequal? Isn't it? That sounds just a repetition of the same thing. True, true. There is nothing new. I can say this is again like a rephrased statement of the third law, but you have to remember this thing very precisely because sometimes while doing numericals, you might get confused initially that when you see two forces and you are trying to figure out that are they action and reaction or not. When you come under this confusion that you are able to see two forces and you want to figure out whether they are action or reaction, at that time this point will also be helpful. They can never be unequal. So if you visualize that situation and if you see that yes, there is a possibility that maybe these two forces become unequal, so under those conditions it's sure it can't be the action and reaction. Okay, so I expect that we will remember these 5 points about Newton's laws. So now let's proceed towards the next segment. After these three laws, now there are a few small topics or small names, and we would like to just go through them so that probably by tomorrow we can try some numericals. Okay, so I'm going in that direction. Let's first understand the term weight. What do we mean by the weight of a body? Right now, I'll be speaking in a way as if my definition is going to be observed on Earth only. And that's quite true. So, my point is that I'm not going to give you a universal definition for the weight. The word weight will have significance when you are talking with respect to some planet or some satellite or some structure weight. Okay, so with respect to the earth, right now I'll be speaking WRT. We use this abbreviation for with respect to. So I'll be speaking with respect to earth only. This abbreviation will be used very frequently later on, so let's all be familiar with this. WRT means with respect to earth. So what is weight of a body? We say that weight is that force by which the earth attracts any body towards its own center. All right. I mean that say if this is the earth and if some m mass is kept here, let us say this is a block A. Now this block A will experience a force towards the center of earth. Okay, this force by the earth, this force by the earth on the body towards the center of earth. That's what we call as weight. So be clear, weight is a force. Okay, weight is a force, mass is not a force. For a body to have a weight, it needs to have mass, but I hope we are already clear, and if not, then let's be clear that mass and weight are not the same thing. Mass is one of the fundamental quantities, whereas weight is a force. All right. So, weight is the force by the earth on the body towards the center of earth. If m is the mass of body and g is acceleration due to gravity, then the weight of the body is given by m into g. M is for mass, G is for acceleration due to gravity, and yeah, of course, capital W is the weight. All right. So, whenever there are any questions in which weight is involved, that this is the weight of a body on earth, then we have to be clear that the weight is the force with which the body is attracted towards the center of earth. It depends upon the mass of body and the acceleration due to gravity. Now, see, on the earth, the value of this g is almost 9.8. Uh, if you go on some other planet, the value of this G may be more or less. I hope we have heard it somewhere that on the moon, the acceleration due to gravity is approximately 1/6 of the gravity on Earth. So, if the weight of a body is mg on Earth, then the weight of the same body will be mg by 6 on moon. Why? Because the acceleration due to gravity would have reduced. So, when I said that I am writing weight with respect to Earth, I meant I am going to take G as 9.8. All right. So, since weight can be expressed as mg, G 9.8 meter per second square, and you will see that in many numerical situations, the G may be approximately taken as a 10 meter per second square. This type of symbol, these two waves, one over the other, this is the symbol for approximately equal to. When you are going with a little rounding off, or if you are going to ignore some places after the decimal, then we use this type of symbol. So, yes, G is actually close to 9.8, but in many situations, you can take it like 10. For my calculations, for my questions which I'll be doing, I'll be going with G as 10. It keeps the multiplications easy, it keeps the number symmetric. So that's why we'll go with 10. So I mean that if my mass is 90 kg, then my weight my weight will be mg. M means 90 and g is 10. So I'll say my weight is 900 newtons. All right. So remember, the unit of the weight will be in Newton because it is a force. But yes, there are other systems of units also used. Especially when we speak about the gravitational force, there is one more way to write. See, if I don't write the value of g here, I can write my weight is 90g, right? And if the weight is 90g, we can also write it like 90 kilogram weight. So we write this WT for the weight, 90 kg weight. So this 90 kg weight is same as 90 into G newtons. Got it? So if I say that the weight of a body is 5 kilogram weight, so I mean I'm talking about that force which will be experienced by a body whose mass is 5 kg, that is 50 Newton. All right. So suppose right now I say that I'm exerting a force of zero point 0.1 kilogram weight on this. I'm exerting a force of zero point 0.1 kilogram weight on this. I mean, I'm exerting that force which is equal to the gravitational force on zero point 0.1 kg. Fine. So just keep in mind this thing when we say 1 kilogram weight, we actually mean 9.8 Newton, or to round off, I can say 10 Newton. Fine. Uh, Now let's understand one thing also. When I say that the weight is given by mg, and the weight depends on the value of acceleration due to gravity. I told you that for the different planets, the gravity may be different, but actually, even on the Earth, also at different locations, the gravity can be different. The value of this g as 9.8 meter per second square, actually, that is the value on the surface of Earth. So if suppose you measure the acceleration due to gravity here, you will get 9.8 meters square. But actually, suppose if you go very far away from the Earth, when I say very far away, let me say that the height of this point from the surface of Earth is equal to the radius of Earth itself. Okay, so let me call that point as a B, let me call that point as a A. So if at point A, the acceleration due to gravity was 9.8, at B, if you do the calculation, the acceleration due to gravity will be approximately 2.45 meter per second square. Approximately, okay. The second place of the decimal may not be correct. Uh, the point is that as you start going away from the surface of Earth, the acceleration due to gravity decreases. And by the time you reach this location, when the height from the surface of Earth becomes equal to the radius of Earth, at this point, gravity becomes g by 4. When I say g, I mean the gravity on the surface of Earth. So since this number was close to 10, so this number was close to 2.5. Got it? So we should know this thing. Acceleration due to gravity is not constant around Earth at any point. Yes, as long as we are on the surface of Earth, the gravity acceleration will be almost same. But as you start going away, it starts changing. All right. Especially, not specially, I mean, from our exam experience point of view, I'm sorry. From our experience point of view, the highest point where we can go from the surface of Earth is that time when we are traveling by some airplane. If you are flying from one town to other, and if you are using any some civil plane, most of these civil planes fly up to the height of 10 kilometers. You would have read that somewhere they're out to 35,000 feet, right? So the maximum height up to which these civil planes go is 35,000 feet, which is like approximately 10 kilometers. Okay. Now, when you are only up by 10 kilometer, yes, the gravity decreases in those 10 kilometers also, but that decrease is almost, I can say, 0.3%. On the height of 10 kilometers, the acceleration due to gravity decreases almost by 0.3%. So, since the difference is so small, we are not able to experience that. The change is very small. For example, I said if my weight is 900, so if you calculate the 0.3% of 900, how much it would be? 3, right? 1% of 900 is 9, and approximately one third of it is further 3. So now tell me, if I experience a force of 900 Newton or I experience a force of 903 Newton, aren't they very close to each other? Right? Or actually, the force decreases as we go high. So I should not say rather 903, I should say my weight should become 897. Well, but the point is that if the change is very small, we are not able to observe it. To observe the change in the gravitational acceleration, we have to go to higher heights, which unluckily we are not able to go because the civil planes don't take us beyond that. To experience the change in the gravity, we have to at least go maybe till a height of say 1,000 kilometers up from the surface of Earth, which we can't go, right? So this was the idea about the variation in the gravity. Fine. Now understand one thing that suppose this is the ground. I put a weighing machine on the ground. Okay. This is a weighing machine or weighing scale, whatever we call it. And now let us expect that a man is standing on it. So there is a man standing on a weighing scale. Let us say the mass of the man is m, and of course he is on earth. So the acceleration due to gravity is present in the downward direction. We would like to know that what is the reading of the weighing scale. Okay. Now understand one thing. The weighing scale can show the force exerted by the feet of the man on this surface. Okay. Weighing scale is not a smart instrument that it knows that you are coming for your weight, so how to calculate that? No. Weighing scale is a very rudimentary type of apparatus which can only show the force which is coming from the upper surface. Those of you who are having this weighing scale at home, you would have certainly tried it sometime that if you put the weighing scale, you don't stand on it, you simply press it down. If you press it with your hands, you will see that the reading changes. Maybe you can press it hard and you can show the reading of maybe up to 10 kg, 12 kg. Or if you simply put 1 foot on this, you don't stand on it, you simply put your 1 foot on the weighing scale and you are trying to press it and you will see it shows the reading. The display of this weighing scale changes. So let's understand one thing. How does a weighing scale shows the weight? The answer is the weighing scale only force exerted by the feet of the man on the upper surface of the weighing scale. I am emphasizing on this line. Yeah, I am saying that on this line, I made it an orange color. At this line, the man is pressing the weighing scale down and the weighing scale is pushing the man up. Can we say so? Because of the gravitational attraction, the man was pulled down, and since weighing machine came in between, so now because of the gravitational force, the man has a tendency to go down, and since his feet are in contact with the weighing scale, now the feet are pressing the weighing scale. Okay, so can I say that in this situation, the weighing scale experiences a downward force? Let me do this thing. I show the weighing scale here. I'm calling it a WS, weighing scale. It experiences a downwards force exerted by the man, and I'll say the man will experience the same force but in opposite direction exerted by the weighing scale. So number one, my question is this force and this force, are they action and reaction? Are they action and reaction? Yes. Yes, they are action and reaction. The weighing scale is pushing the man up and the man is pushing the weighing scale down. So, whatever this force is present, either you call the force by the weighing machine or force by the man, I'll say the weighing machine will show a reading which is equal to either force by weighing scale, or I can say force by the man. Oh, not man, man. So actually, these two are one and the same. Therefore, I can say that the reading of a weighing machine will be actually the force which is present between the feet and the weighing scale. Okay. So this is how we are able to see the weight, or we are able to measure the weight simply by standing on a weighing machine. But we should understand that it will give the right reading only when, for example, you are standing and nobody is pressing the weighing scale from somewhere else. Few people do this type of prank also. There are few people who are very skeptical about their weight. So once they stand, somebody will surprisingly press the weighing scale from some side. If somebody is pressing from this side, of course the reading will go higher, right? So yes, except you standing on it, there should be no such force. Number one. Number two, you are also standing, but you should not also be in contact with anything around you. Tell me one thing. Let's take of an example. Uh, this is the floor. This is the weighing scale, and you are standing here. And these are your hands now. So I'm saying if you stand like this, yes, your weighing machine will show your correct weight. But now, suppose if I say there was some rod suspended somewhere on the upper side, let me say that here is a very strong rod which is supported by some extra walls. Understood? Suppose right now I am standing here, a rod is going from top, and on one side it is fixed with one wall, on the other side it is fixed with another wall. That type of assembly what we have for the curtains at home. पर्दे कैसे लगाए जाते हैं? दोनों तरफ clamps होते हैं. There are clamps on both the sides. So assume that such a structure is here. Now tell me, if you are holding this rod and you are standing on the weighing machine, and now tell me what happens if you start pulling it down. You are not actually pulling yourself up. I'm saying you are just trying to pull the bar down. You are actually trying to bring the bar down, or I can say you are trying to lift yourself up, but you don't exert complete force. You simply hold the rod and you exert a little force in the downward direction. If you do so, should the reading of the weighing machine decrease? What do you think? If you hold the rod and you're trying to pull the rod down, when you are trying to pull the rod down, the rod will try to pull you up. Okay. So, will that upwards force change the reading of this weighing machine or not? Yes. And in fact, if you are strong enough and if you are exerting sufficient amount of force, you will see that if you keep on pulling it down harder, 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 and at some point of time, maybe your feet will raise from the weighing scale and it will show the reading zero. So my point is that if you were increasing your force gradually, suppose your weight is 50 kg. So while you exert your force, you increase it gradually, would you be able to see this reading decreasing from 50 gradually, 50, 40, 30, 20, and 0? Can we see that change in the reading? Yes. Yes, we can see that. So, since the reading can change, let's understand one thing. Weighing scale is not a magical machine that you simply come in contact with it. आप इसको ऐसे touch कर दो यहाँ से, this can show your weight, or you simply put your hand on it, it will show your weight. No, you have to stand on it, and your body should not be in contact with any of the neighboring walls or something like this. Fine. Third condition, you should keep standing still also. If you are standing on the weighing machine, but instead of standing still, what you start doing? You start doing these half squats. You start raising yourself, getting up, start doing this thing. So, if you do this thing on the weighing scale and if you keep on watching the display, you will see the display is all the time changing. If you are having weighing scales at your home, you can just try that after the class, stand on it and simply do this thing. Keep on doing this thing for 4 or 5 seconds and have a look on the reading below. You will see that the reading is all the time changing. And also you will observe one thing. Sorry. If your actual weight is, let us say, 50. If you stand on the weighing scale shows 50 kg. Now, if you start doing this thing, I said, come down, go up, come down, go up. If you do this thing, you will see that sometime the weight will be more than 50 and sometime it will be less than 50. You will get both the readings. There must be some number which is maybe 51, 52, and there must be some number 48, 49, or maybe 49.5. But you will see that the readings will be shifting in both the directions. Okay. And even to be more precise, when you are going down, you will see the reading is small. When you go up, you will see the reading is more. So I go down, reading becomes 48. I stay myself like that, reading is 50. I come up, the reading becomes maybe 51, 52. So the downwards motion will give you lesser reading. Stable situation will give you the true reading. And when we are raising ourselves, at that time you get a bigger reading. Why is it happening? This also we will understand. But my point right now is to make you understand that weighing machine is not a magical machine which will always show your weight. It is only going to show you the force between the feet and the surface. Okay. Or simply speaking, I can say any weighing machine will show that force which is exerted on it. That's it. It is as simple as that. If this force coming from top side is equal to your weight, then you can see your true reading, true weight. And if the force is not equal to the weight, then you will see something else. The weighing machine is a force measuring instrument, as simple as that. All right. So, coming on the previous page, now I would like you people to focus on these forces which I have shown. I mean, this force and this force. I said they are action and reaction forces, right? Okay. Uh, Action and reaction forces are present in gravity also. Action reaction forces are present in electrostatic also. Here, what is the name of that force? What is that source of the force which is acting between these two? We use a word normal contact force. Normal word is similar to the perpendicular. If suppose I say this hand represents a flat surface, a plane, then the direction which is like this is what we call as the normal. You can see it from different directions. A normal is a line which is coming out from a flat surface in such a way that this line will make 90-degree angle with any line on my hand. So that's what we call as the normal. Okay. So a flat surface can have a normal this way also, it can have a normal this way also. For one flat surface, two directions of normal are possible. So the word normal comes from the direction. Contact force. Yes. What do I mean by contact force? Those forces which come into action only when there is a contact, right? The simplest example is a clap. When does this clap sound is heard? When one surface is coming in contact with the second surface, and when they exert a force on each other, because of this force, some vibrations are generated and you hear a sound. But tell me, if I just bring it very close but I don't touch it, if just before touching, if my hand just stop, would you get any sound? Would you get any force? No. So these are those forces which do not act without the physical contact. We call them as the contact force. All right. So this type of forces are present in so many situations. Suppose if I say this is a horizontal surface and here is a block. So I would say that in this situation, the block experiences a normal force by the floor in the upward direction, and the floor experiences equal and opposite force in the downward direction. So this is a normal reaction force. I'm using NRF for that. Normal contact force I had to call it. Normal contact force, NCF. This is also an example of NCF. If you are having two blocks, one over the other, now I will say if this is A, this is B. A is experiencing a normal contact force in the upward direction and B is experiencing the same normal contact force in the downward direction. These two are action and reaction pair. A is pushing B down and B is pushing A up. So this is an example of normal contact force. The bee is also experiencing a force from the ground. Since B is pushing the ground also, so there should be one more normal contact force, but this force and this force need not be equal. So I'm just using a prime symbol for this, just to show that this force and that force is different. So B is experiencing two normal contact force, one from the A, one from the floor. The floor will experience a normal contact force from B only. The floor does not experience a normal contact force from A because A is not touching the floor. I told you the contact force will come into action only when there is a physical contact. If you look at the situation, A is not touching the floor. If A is not touching the floor, how can A exert any force on floor directly? That's why you see on the floor there is just NCF dash. That means this is the reaction of this force. So I mean to say that this force and this force are action and reaction. This force and this force are also action and reaction. So now I want you to understand that when a person is standing on the weighing machine, now this, let's remove this thing. The man is only on the weighing machine. So for this man, I would say one is the force of gravity, another is a normal contact force given by the weighing machine. So this man is experiencing these two forces, Fg and a normal contact force. And if I show the weighing machine would be experiencing a normal contact force by the man on the machine. So actually this NCF and this NCF, they are action and reaction pair. Got it? So time's up. That's all for today. Tomorrow again, we'll continue this thing and take few more interesting situations. Fine. So that's all for today. Bye bye. Have a good day.
Yeah. Good morning, everyone. How are you? So today we are going to learn a new topic, that is basics of mole concept, and mainly in today's class we are going to concentrate on the atomic mass and molecular mass concept, and what is mole, how to calculate the moles if they are giving you mass, if they are giving you volume, if they are giving you number of molecules, how to calculate the mole, we are going to concentrate. Okay guys, let's start now. What is the name of the topic? Basics of mole concept. Is the topic we are going to start. Yeah, good morning. Okay, fine. But it is a basic concept. No, we are going to learn again, right? So, what is atomic mass? We are going to learn first. Atomic mass of an element is determined by taking carbon 12 isotope as a standard. Yeah, good morning. My voice is reaching, I think, properly. So, carbon 12 isotope is taken as a standard, and we are going to find the atomic mass of any element available on the Earth. So, we also call this as relative atomic mass. Okay. What is meant by atomic mass of element? Atomic mass of an element is the mass of an atom of element heavier than 1/12 of carbon 12 isotope. This atomic mass is also known as relative atomic mass because by using carbon 12 we are finding the atomic mass of other elements. How to write relative atomic mass formula? Mass of an atom of element divided by 1/12 of carbon 12 isotope. This is atomic mass or relative atomic mass. What are the units you are using for this? Anyone? Anyone in the group, please mention. What is the proton plus neutron? That is the mass number. This is not the atomic mass. Atomic mass is determined by taking the carbon 12 isotope as a standard. Okay. Anyone in the group, please mention what is the unit you are using. Yeah, very good, very good, very good. Manikumar, very nice. Rakesh, very good. Yeah, Fatima, right. So we are using AMU as the unit for measuring the atomic mass. One AMU is having mass equal to 1.67 into 10 to the power of minus 24 grams or 1.67 into 10 to the power of minus 27 kg. So if you are done with the copying part, I will take the next page. Shall I move on? Okay then. What are the units you are using here? Units. AMU or U. What is U? Unified mass. What is AMU? Atomic mass unit. One AMU is having, what is the value of one AMU? 1.67 into 10 to the power of minus 27 kg or 1.66 into 10 to the power of minus 24 grams. Okay. Very nice. Very nice. Varun? Yeah. Again, I am explaining once again. Listen carefully. If you are measuring the atomic mass of an element, mass of atom of an element, one atom of an element, how to measure? By using the carbon 12 isotope we have to use. See this. By using the carbon 12 isotope we have to use. Yeah, see this ones. Yeah, I am explaining. If you want to measure the mass of an atom of element, one element, not the total, atoms present in that. One atom, if you want to measure, we can measure by taking the carbon 12 isotope, mass of one atom of carbon 12 isotope. What is the atom AMU then? 1.66 into 10 to the power of minus 27 kg. Okay, mass of an atom of element. How we are measuring? By taking the carbon 12 isotope as a standard. And what is the unit you are using? Take a screenshot then. Yeah, I think you are done with that part. It is AMU value. Okay, I will use different colors, no problem. White is best. We'll use white color. Now, I think you already learned in your 10th class or 9th class. What is the atomic mass of the following elements? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. You can mention in the group. Atomic masses. Iron we can take later. Yeah. Atomic mass of hydrogen. One, very good. Helium. Helium. 1 4. Okay, nice. 147. Beryllium. Next. What else? Carbon, nitrogen, oxygen, fluorine, neon is 20. It is not important for us. You already have some idea, at least some idea on this. But if they are giving you chlorine, it will be having a fractional value 35.5. Why? We are going to learn about that. We are going to take the average atomic mass into consideration. If you take chlorine, its value is 35.5. Why it is 35.5? Atomic mass is 35.5. I am taking the next page. See this ones. Average atomic mass. Average atomic mass. When we are going to take into consideration if an element is having two or more isotopes, and if each isotope is having considerable availability on the earth, then what you are going to take? Then average atomic mass is taken into consideration. What is this average atomic mass? How to find it? Average atomic mass is equal to, for example, listen, abundance is different. Yeah, different. Yes, correct. If you're taking chlorine, there are two isotopes of chlorine. It is available in two forms. Chlorine 35, chlorine 37. Percentage of chlorine 35 is 75% on the earth, whereas chlorine 37 is only 25% on the earth. So percentage availability is not same, they are different. So in that case, we have to use this formula. Use this condition. Okay. Average atomic mass is equal to atomic mass of isotope 1 into percentage availability plus atomic mass of isotope 2 into percentage availability or abundance divided by 100, whole divided by 100. For example, we are going to discuss an example now. Sir, previous slide please. Okay. Okay, fine. I'll show you the previous slide. Yeah. This one. Okay, done. Thank you. See this. We are going to find the average atomic mass and also percentage abundance. Two examples we are going to discuss now. First one, we are taking the example of chlorine. See this. Find the question number. Find the average atomic mass of chlorine if chlorine is having two isotopes. Two isotopes. What are they? Chlorine 35, chlorine 37. Percentage availability is 75 percentage and 25 percentage. Can you apply the formula now? Can you apply the formula? Can you apply the formula? Check the formula what I gave you. There are two isotopes. Average atomic mass is equal to atomic mass of the first isotope 35, percentage abundance. What is the percentage abundance they mentioned? I mentioned here 75 plus 37 into 25 whole divided by 100. 35.5. Very nice. Yeah, I will show the formula once again. Atomic mass of first isotope into percentage availability plus atomic mass of second isotope into percentage availability. If three isotopes are there, percentage abundance of first isotope into atomic mass of first isotope, atomic mass of second isotope into percentage availability of second isotope, plus whatever third one, same like that. If four are there, four we have to take. If they are mentioning clearly. So what is the value you are going to get if you solve this? 35.5 U. 35.5 U. Very nice, good. Very nice. Why take 75 and 25%, not 50 and 50%? See, what is her name? Himanshu Goyal. It is not depending upon us. It is really available like that on the earth. For example, if you are taking oxygen, oxygen is also having isotopes. But dominating one is 16, oxygen 16, which you are breathing. Along with that, other isotopes are there. Same like that, if you are taking carbon, there are two isotopes, carbon 12 and carbon 14. Carbon 14 is also present in us, but it is not dominating. It will be present in our body. Once we die, it will be start disintegrating, it will be coming out. See, we know that how to find we are finding the age of the fossils. How we are finding that? By using carbon 14, not carbon 12. It is coming out, disintegrating once we die. Not every element, yeah, carbon dating, right? Ananya Kumari, correct, carbon dating. We are finding that. Yeah. Then why do they have long decimal number? See, that's the thing. Depending upon the percentage, if the percentage is too high like this, then average we are going to get. But that percentages are generally not very high. But in the case of chlorine, it is very high. That's why we are taking 35.5. Other elements are also having, but very less like this. Okay, continue. Condition 2 or case 2 we are going to do now. Finding the percentage abundance if average atomic mass is given. Okay. Example. Find the percentage of boron 10, boron 11 if the average atomic mass of boron is 10.8 U. 10.8 U. Okay. Now how to find it? Solution. Average atomic mass 10.8 is equal to atomic mass of the first isotope boron 10 into, we don't know how much it is present, so what we are doing, we will take it as x. Okay, then plus remaining 11 into, we don't know how much is present, 100 minus x divided by 100. Solve this. 10x, 10 into x plus 11 into 100 minus x. Total it should be equal to 100. Okay, so what is the value you are going to get? Please find it now. See this, it will be equal to 1080 if it is coming here. 10 into x plus 1100 minus 11x. So what is this value? Minus 20 equal to how much? Minus 10. Minus 1, correct? So percentage of boron 10 is equal to 80 percentage. Percentage of boron 11 equal to, sorry, other way around I have written, is 20 percentage and other is 80 percentage, because it is, we have taken it as 100 minus x. This is x is 20. Understood this one? Right? Very good, math. Naman Singh, nice. Manikumar, good. Subhan Reddy, very good, guys, very good. I'll give one more question. You want to complete it so that we can go to the mole concept? Yeah, very good, guys. Continue. One more example I'll give you, then we'll go to the mole concept. What is mole? How to calculate the targeted topic? We are going to find. Okay, we are going to learn now. So I am continuing then. If the average atomic mass of bromine is 80, find the percentage abundance of bromine 79, bromine 81. Same formula, apply it. Yeah, good morning, Mr. Dinesh Gaud, Emmanuel. Same formula again. Same formula, Emmanuel. So, average atomic mass. What is average atomic mass? 80 is equal to atomic mass of first isotope 79 into, we don't know how much is present. What you have to do? X plus 81 into 100 minus x. It is for 100% only. So minus x by 100. So what is the value you are going to get? Very nice, 50-50 percentage. Very good, guys. We will get x is equal to 50. So percentage of bromine 79 is equal to 50 percentage. Percentage of bromine 81 is also equal to 50 percentage. Nice, guys. Nice, nice. Nice. 50-50 percentage. Good. Good, guys. So we got some idea on the atomic masses. Now we are going to learn about the molecular mass. Okay, how to find the molecular mass of the molecule if they are giving you formula mass, molecular mass. Both we are going to find. Once you are ready, I will start. Anyone still copy? I hope so, everyone. Right, guys. Molecular mass in a simplest terminology. And one more thing, yeah, yesterday's class PDF will be shared by sir. After the class, I'll inform. Okay, Mr. Sharon Tej, right? Okay, then. So, now molecular mass. Actually, whenever we are using the terminology molecular mass, this terminology is applicable for the covalent compounds, molecular mass. So, for the ionic compounds, we have to use the terminology formula mass. For the covalent compounds, we have to use the terminology molecular mass. Okay? How can we find this? It is the sum of the atomic masses of all the elements present in the molecule. Okay, this is applicable for the covalent compounds. One point you should keep in the mind: whatever we are doing till now, its units are only U, AMU or U. But if I say gram molecular mass or gram atomic mass, then its units will become grams. Till that time, that units are U only or AMU. Please keep it in the mind. As long as I am saying molecular mass or atomic mass, units are U only. If I am saying gram atomic mass, gram molecular mass, it will become G, grams. Both are not same, different. It is for one molecule. Okay, for mass of one molecule we are finding, that is called as molecular mass. If you are finding the 1 mole of a molecule, that is gram molecular mass. Okay, yes, you learned this in the covalent compounds, covalent bonding chapter. Sharing of electrons takes place, correct, Mr. Shubhan Reddy, correct, Mr. Covalent compounds, simply it is a sum of the atomic masses of all the elements present in a compound. Example, we are finding the molecular mass of glucose, water molecule, sucrose. Let's start with the glucose. Identifying the number of atoms for each element in the chemical formula, multiplying. Yeah, correct. How many atoms are there in this molecule? How many carbons are there? 6. 6 into C, atomic mass of carbon, plus 12 into hydrogens. There are 12 hydrogens here. Plus 6 into O, oxygens. What is the atomic mass of carbon? We know that it is how much? 12. 6 into 12 plus hydrogen is 1 plus oxygen is 16. 16 6 are 96, correct? So what is the total value you are going to get? 12 6 are 72 plus 12 plus 96. It is how much? 180 u. Always u. We have to write beside that 180 u. If I am writing 180 g, it will be different. 180 u means, again I am saying, if you are finding the mass of one molecule, it is molecular mass. If you are finding the mass of total moles in the molecule, if they are giving you, right? Correct. Water. Find it. For water. Find it, guys. Explain again. Some person. Sorry. Yeah. See, if you are finding the mass of one molecule, we are finding right now only one molecule. Till the time, keep in the mind only one molecule. Then it is molecular mass. If you are finding for 1 mole of molecule, 1 mole, I will explain you what is mole, then you will get an idea. Right. So, water, 2 into hydrogen plus 1 oxygen. What is the value? You are going to get 2 into 1 plus 16, it is 18U. Sucrose. Find for sucrose. What is the value you are going to get for sucrose? 12 into C plus 22 into H plus 11 into O. Answer I want, guys. What is the answer? Yeah, very good. Yogeshwaran, very nice. Shubhan Reddy, nice. Not 110. Not 110. 12 12s are. Atomic mass of carbon is 12. 12 12s are 144. 22 into 1. 11 into 16. So 160 plus 16, it will become 176. 176 plus 22 plus 144, it is equal to 342U. Correct. One more example I will give you. I will not write answer on the board. You do it and tell me the answer. NH2 C double bond to NH2. Urea. Urea. Not 144. Ananya Kumari. Ananya C6H12O6. 12 6 are 72. H12 plus 12. O6. 96. 16 6 are 96. 96 plus 72 plus 12. Okay. There are two nitrogens. 2 into nitrogens. 4 hydrogens. 4 into hydrogens. 1 carbon. 1 carbon. 1 oxygen. 1 oxygen. Okay. Now, what is atomic mass of yes, what is atomic mass of nitrogen? 14 plus 4 plus 12 plus 16. Answer. Already some students mentioned 60. Very good. Very good. Very nice. Correct. 60U is the correct answer. 60U is the correct answer, guys. So, any molecule you take, but you should have idea. You can find for the ionic compounds also. Same concept you can use. But one problem is there. If they are asking you whether it is a molecular mass or formula mass, without knowing the type of bonding, we can't say, because same methodology you are going to apply. In this case, the type of bonding is covalent bonding. In that case, it is ionic, means complete transfer of electrons. Nitrogen atomic number is 7. Atomic mass is 14. Yes, correct. Atomic number is 7, but atomic mass is 14. Shall I move on? Shall I take next page now? Now see this. If you are taking ionic compounds, what you are using? Formula mass. formula mass. Examples if you're taking, what is the nature of bonding present here? Ionic bond. Sodium chloride, potassium chloride, sodium sulfate, like this we are taking now. Same methodology. What you applied earlier, same you have to apply. But the type of bonding is different here. That's all. These are bonds between the, like, not actually bond is not present. It is just a sharing of electrons between a metal and non-metal. Now take here sodium chloride. What is atomic mass of sodium? 23 plus chlorine 35.5. How much it will be? 58.5. Very nice. Naman Singh. Naman Singh, correct. 58.5 U is correct answer. Potassium chloride. There is one potassium, one chlorine. One potassium, one chlorine. What is the mass then? Potassium is 39, chlorine is 35.5. Answer NEET 74.5. Very nice. Maniket Anand. Very nice. Fatima, good. Nice guys. 74.5 U. Sodium sulfate without my support, do it guys. There are two sodiums. 2 into sodium plus sulfur plus 4 into oxygen. Do it now and give the answer guys. 2 into sodium plus sulfur plus 4 into oxygen. 142 you got? Let's check now. 2 into sodium 23, sulfur 32, 4 into oxygens. 16 fours are 64. 46 plus 32 plus 64. Yeah, correct. 142 U. Very nice, very nice. Very good. Chandrahas. Before slide, check once faster. Check once faster. Okay, completed. Very good. We are going to learn about mole. What is mole? And we are going to enter into a very beautiful topic. Okay, I am from SR Nagar. Previous slide, just now I shown, no, I will show you again. We will continue small part. Okay, guys? Right now, see, mole. What is mole? Actually, it is a collection of entities or species. Same like our currency, if you want to measure how many atoms are there, how many molecules are there, we can measure by using this mole concept. Okay? One mole of any element, please keep in the mind, elements means sodium, potassium, like that you have to take. I will give clear idea on this topic. One mole of any element contains same number of atoms as present in 1 mole of carbon 12 isotope, means 12 grams. What is this point I will mention? Mole is collection of what? Entities or species. One mole of any element is having same number of atoms as present in 12 grams of carbon 12 isotope. How many atoms are present in 12 grams of carbon 12 isotopes? Avogadro number. Avogadro number. What is this number? 6.023 into 10 to the power of 23. That means if they are saying 1 mole of sodium, 1 mole of sodium contains how many atoms? Avogadro number of sodium atoms. What is the mass of then 1 mole of sodium? 1 mole of sodium is having mass of 1 mole of any element is equal to its gram atomic mass. Gram atomic mass. Now first time I am using the terminology gram. We will go deep into the topic, don't worry at all. I will give clear idea on this. Number of any substance in 1 mole is equal to Avogadro number. Actually, why I am saying element and molecule, you will get an idea. Because I have to introduce the terminologies, gram atomic mass and gram molecular mass. So I should not be in a generalized way, okay? I should be more particular here. Please check once. So mole is collection of entities or species like electrons, protons, atoms, molecules. How many atoms are there? We can calculate them by using mole. 1 mole of any element is having same number of atoms present in the 12 grams of carbon 12 isotope. How many are there in that? Avogadro number. Shall I take next page now so that we can have a clear understanding on the topic? Right. Find the number of atoms in 2 moles of aluminum. Okay. Now, yeah, gram atomic mass I'm going to teach. Don't worry. Atomic mass measured in the grams, I'm going to write it on the board. I will explain you clearly. Now, find the number of atoms. We know that 1 mole of aluminum is having mass equal to 27 grams. Gram atomic mass. I will write here on the board. If they are giving you 2 moles of aluminum, X. But they are not asking mass, no? Number of atoms. How many atoms are there in 1 mole? Avogadro number. It is question mark. So what is the value of X? 2 into Avogadro number by 1. 2 into 6.023 into 10 to the power of 23. That is 12.046 into 10 to the power of 23. Atoms of aluminum. Very nice, very nice, very nice, very nice. 1 mole of any element, if you are taking, it is having Avogadro number of atoms. Okay, now I am going to introduce the terminology GAM, gram atomic mass. Gram atomic mass. Gram atomic mass. Mass of if atomic mass is measured in grams. Measured in grams. What is this measured in grams? I will tell you. In the case of atomic mass earlier, what is Avogadro? Yeah, it is a number given by Avogadro, a scientist. Emmanuel Avogadro is a scientist. He measured number of atoms present in a carbon 12 12 grams of carbon-12 he has taken as a standard. He found that 1 mole of carbon contains Avogadro number of atoms, means 6.022 into 10 to the power 23. Also, he is the one, he said that if you are taking 1 mole of any element on the earth, it contains Avogadro number of atoms only. Any element on the earth. Okay? Shall I take next page so that I can clearly explain about the gram atomic mass? Right? Now, difference between gram atomic mass and atomic mass. If you are taking gram atomic mass is mass of 1 mole of an element. Here, mass of 1 atom of element. Here, units we are using here for measuring grams. Here, AMU or U. Here, for example, they are giving you sulfur, gram atomic mass 32 grams. It is 32 U. Both are not same. Both are not same. It is for one atom. It is for one atom. U value already gave you 1.67 into 10 to the power of minus 27 grams, minus 24 grams or 27 kg. But it is 32 grams for 1 mole. Avogadro number of atoms we are taking. Got it? I think you understood this point. Clearly, I gave the separation between them. Any one doubt you are having, you can ask me here clearly. I will explain. Yeah, explain about atomic mass. I explained it clearly. If you are taking atomic mass, we are taking only one atom of the element, one atom. If you are taking Avogadro number of atoms, means 6.023 into 10 to the power of 23, we call that as 1 mole, and its mass is its gram atomic mass. One atom if you are taking, that is atomic mass. If you are taking 1 mole of atoms, then gram atomic mass. Means if you are taking 1 mole of an element, then it is gram atomic mass. Sir, but 1 mole of sulfur will be Avogadro number. No, mass is equal to gram atomic mass. Contains Avogadro number of atoms. It contains how many atoms? Number of atoms here is equal to Avogadro number of sulfur atoms. How many atoms are there in this case? Number of atoms equal to 1. Only one atom. No, relative atomic mass and atomic mass are one and the same. Gram atomic mass and atomic mass are different. Gram atomic mass is for one atom. Sorry, atomic mass is for one atom. Relative atomic mass and atomic mass are one and the same. Again, I am repeating. If you are finding for one atom, that is relative atomic mass or atomic mass. If you are finding for 1 mole or Avogadro number of atoms, then it is gram atomic mass. Case 2. See here. Here we learned about this one, 1 mole of any element. Now 1 mole of any molecule. Second case, case 2. 1 mole of any molecule is having mass equal to its gram molecular mass, and it contains Avogadro number of molecules. For example, if you are taking here water, 1 mole, we are finding gram molecular mass here. Here, water we are taking 1 molecule. What is the mass here? 18 grams here. What is mass here? 18 U. Number of molecules present here? Avogadro number of water molecules. Number of molecules here. How many molecules are there? One molecule. I hope so it is clear for you now. I hope so it is clear for you. Whenever I am mentioning gram molecular mass means we are taking mole. In grams we are measuring. Gram molecular mass means in grams we are measuring. Atomic mass means U. U, whenever you are saying U means only one molecule. Gram atomic mass means atomic mass means only one atom. Molecular mass means only one molecule. Right? Shall I move on? If you understood this concept, shall I move on? Right? Very good. Akshat, again I will explain you what are 18 grams. Again I will take one more example. Akshat, you be with me. We will do again. I am giving you a molecule example. Carbon dioxide, Akshat. Okay. If I am taking here molecular mass, here gram molecular mass, both are having same value but different units. This is how much? 12 plus 32, 44 grams. It is equal to 44 U. Here number of molecules present. How many molecules present? Avogadro number of molecules are present. Why? It is equal to 1 mole. 1 mole of any molecules contains Avogadro number of molecules. Here, number of molecules. How many are there? 1 molecule. Okay, that is the difference between these two. Got it? Akshat? Akshat Sinha. Done now? Yeah. That is the difference. Whenever they are saying gram molecular mass or molecular mass, please keep it in the mind what we are doing. Right. Previous slide. Check once. Faster. Yeah, you can take screenshot, mister. One mole of any molecule is having Avogadro number of molecules. Naman Singh. 1 mole of any molecule contains Avogadro number of molecules. Fixed. 1 mole of any element contains Avogadro number of atoms. 1 mole of any molecule is having mass equal to its gram molecular mass. Naman Singh again. 1 mole of any element is having mass equal to its gram atomic mass. Naman Singh, got the point? Naman Singh? Yeah. Now, there is a flow chart for mole concept. What is a flow chart? See here. Here we are having mole in the junction. We are having mass on the top. Here we are having volume. Here we are having number of molecules. We are having number of atoms at the bottom. This is chart number 1. Flow chart number 1. We are going to find these applicable for molecules. Molecules examples. That also you should have idea. For each and everything we can't take it as a molecule. CO2 is a molecule. SO2 is a molecule. SO3 gas is a molecule. CO gas is a molecule. NO2 is a molecule. NO is a molecule. Helium, neon, argon, krypton, xenon. Like that, if you are taking all are molecules. Then we can apply this one. What you have to write on the arrow? See this clearly. We are moving from mass to mole. Divide by molecular mass. Here into molecular mass into Avogadro number. Divide by Avogadro number into atomicity. Divide by atomicity into 22.4 liters. Divide by 22.4 liters. Today's class, yeah, sir, can noble gases be molecular element? No, no, they are not elements. They are monoatomic molecules. Only one atom is present in the molecule. Noble gases. Diatomic molecules, oxygen, nitrogen, chlorine, fluorine, bromine, they are diatomic molecules. Okay? Then, if you're taking triatomic molecules, they are also present, like ozone gas. O3 is a triatomic gas. NO2, triatomic gas. CO2, triatomic gas. If three atoms are present in a molecule, triatomic. Tetatomic, pentatomic, different are like different are possible. Yes. CO2, H2O, yeah, correct. H2O, triatomic. T4 is a elemental state of phosphorus. S8 is elemental state of sulfur. See this chart once. Now what we are going to do in this class in the remaining how much time we are having? 8 minutes. Only this part we are going to concentrate. Above part. Only above part we are going to solve now in the class. Octatomic acid, Ananya Kumari. Molecular mass. Yeah. No need to take like in a bigger terminology directly. Whatever, for example, if they are mentioning CO2, we have to take 44 divided by 44 like that. Yeah, you can take a screenshot, Mister Akshat. Take it. I will inform to technical person. Okay. Now, case one. Find the number of moles. Mass of carbon dioxide is equal to 4.4 grams. Sulfur dioxide is equal to 128 grams. CH4 is equal to 64 grams. CO is equal to 5.6 grams. NH3 ammonia is equal to 0.34 grams. Now, how to find mole? Mass by molecular mass. 4.4 by 44. 128 divided by, what is the molecular mass of SO2? SO2, first one is 0.1 mole. Here, how we got this? 12 plus 32, 44. This one we are writing here. SO2, what is the molecular mass of SO2? Sulfur 32 plus how much? It will be 32, 64. 128 divided by 64, 2 moles. How many of you got correct answer? Sulfur dioxide 2 moles. Very good. Naman Singh. Maniket Anand. Very nice. Very nice. Continue. Maya Fatima. Very good. Very good. Next one. CH4. Do it without my support. CH4. Very good. Very good. Mass by molecular mass. What is molecular mass of methane? 12 plus 4, 16. 4 moles. CO. CO. 5.6 divided by, what is molecular mass of CO? Very good, 28. Carbon is 12, oxygen is 16. 28. 0.2 moles. Ammonia. Ammonia. 0.34 divided by nitrogen is 14 plus 3, 17. So what is the value you are going to get? 2 into 10 to the power of minus 2. 0.02 moles. How many of you got the correct answer? I will check now. 0.02. Fatima. Very good. Maniket Anand. Very nice. Very nice. Now, reverse you are going to do. Reverse means I will give you moles. You are going to find the mass. Ready, everyone? Shall I start now? Very good. Abur. Right. So, let's take this. Find mass of molecule. Case 2. If number of moles of CO is 2, number of moles of SO3 is 10 to the power of minus 3. Number of moles of CH4 is 1.5. How to do it? See the chart once. I mentioned the chart. Now see this chart. We are here. We are going to the top. Into molecular mass. Mole into molecular mass is equal to mass. Mass is equal to mole into molecular mass. What is the mole value I gave you? 2 into molecular mass of CO. 12 plus 16. How much? 28. What is the answer? 56. Very good. 56 grams. Next. 10 to the power of minus 3 into. What is the molecular mass of SO3? In the chart you have to mention SO3 80. 32 plus 48. 80. So it is 8 into 10 to the power of minus 2 grams. 8 into 10 to the power of, very good. Next. CH4. 1.5 into, what is the molecular mass? 12 plus 4. 16. How can you write this? 16 into 3 by 2. 24 grams. How many of you got the answer? 24. Very good. Very good. Nice, nice, nice. That's all, guys. That's all from my side then. That's all. So tomorrow we are going to go in deep into the mole concept part. I will inform technician person, Mr. Jani Basha. Thank you, guys. Thank you. I'll inform Sharon Teja. I'll inform to him. He will come and do the needful. Okay. Right then, guys. All the best. Do well. So tomorrow we are going to concentrate on the remaining part. Okay, guys. Bye.
So, what did we study in the previous class? What did we study in the previous class? Yeah, I'm fine. I'm absolutely fine. Animal tissues. We started with animal tissues, right? And in the animal tissues, we have completed up to simple epithelium, you know, and some of the modifications of the simple epithelium we have completed till that particular topic, right? Epithelial tissues we have studied. The study of tissues is called as histology or microanatomy. Tissue is nothing but Tissue is nothing but all the cells which are performing similar function are aggregated to form a tissue. They are aggregated to form a tissue, right? Okay, so we studied that there are four types of tissues: epithelial tissue, connective tissue, muscular tissue, and last but not the least is the nervous tissue. Okay, and yesterday we started studying about the epithelial tissue. What is an epithelial tissue? Where is it present? Epithelial cells are present on the basement membrane. Basement membrane is made up of two layers: basal lamina and reticular lamina. What are they actually made up of? Glycoproteins and mucopolysaccharides secreted by the epithelial cells, whereas this is produced, the reticular lamina is produced by the collagen fibers, which are actually produced by the connective tissue itself. And because the cells of epithelial cells are compactly arranged with a very less intercellular matrix, now because intercellular matrix is very less, so what is happening? They are not provided with any type of blood vessels. So they are directly extracting the nutrients from the connective tissue. They are directly extracting the nutrients from the connective tissue, right? This was about the basic introduction about the epithelial tissues. Then we learnt about the different classifications of epithelial tissues based on, first one is number of cell layers. One cell layer is simple epithelium, multiple cell layer is compound epithelium. Simple epithelium, because only one layer is present, it is majorly absorbed, it is majorly responsible for the function of secretion, absorption, and diffusion. Whereas compound epithelium, because it is made up of multiple layers, it is having a very limited role in absorption and secretion. Rather, it is majorly helpful for protection against the mechanical stress. Then simple epithelium is again classified on the basis of the shape of the cell: flat irregular shaped simple squamous for diffusion in the endothelium of blood vessels and alveolar air sacs; cube-like cells in simple cuboidal for secretion and absorption in the PCT of nephron and ducts of the exocrine glands. Next, moving on to the tall cylinder-like cells with the nuclei present at its base, which is responsible for absorption and secretion, present in the inner lining of the stomach and intestine. Now, this cuboidal and columnar can have certain modifications. If it is producing certain secretion, it is called as glandular epithelium. If it is producing certain, if it is having on the free surface, if it is having hair-like structures which move for the movement of the particles, then it is called as a ciliated epithelium. Glandular epithelium can be further divided on the basis of number of cell. Number of cell, single cell. Okay, if it is a unicellular, then it is present in the mucocytes of the intestine. Multicellular, cluster of cells which produce secretion, is nothing but saliva. It is nothing but the saliva. Okay, so this was about the, on the basis of number of cells. Next, we can also classify them on the basis of presence of ducts or absence of duct. Duct having exocrine, what do they produce? They are producing oil, saliva, tears, sebum, etc. Whereas ductless are exocrine glands, endocrine glands, which are producing hormones. These exocrine glands can be further divided on the basis of how are they pouring the secretion. Okay, if the entire cell is getting disintegrated, it is called as holocrine, like the oil glands or sweat glands of the skin. Next, if only the apical part is getting pinched off, apical part of the cell is getting pinched off along with the secretion, then it is called as the apocrine, which is the present in the mammary glands. Next one, coming to the last one, that is merocrine gland, which is nothing but no part of the cell gets disintegrated along with the secretion, then that is what is called as the merocrine gland. That is what is called as the merocrine gland. Okay, so merocrine gland ka example is nothing but the pancreas. It is nothing but pancreas. So this is all that we have studied in case of simple epithelium. And today I said that I will be starting with the compound epithelium. But before I move to compound epithelium, there is a bridge. Okay, that is what is called a pseudostratified epithelium. Pseudostratified epithelium means it is having only one layer of cells. It is having only one layer of cells. But how does it appear? It appears like a multiple layered of cells because it is a simple epithelium. It is called pseudo-stratified. Why pseudo-stratified? Pseudo means false, falsely layered. Why? Because there are some small cells, there are some long cells. So the nuclei is present at different layers. Okay, nuclei is present at different layers. Chalo. Let us start pseudo stratified epithelium. Pseudo stratified epithelium means it is falsely layered. It is falsely layered. Okay, falsely layered in the sense there are different sizes of cells which are present on the same basement membrane, which are present on the same basement membrane. So there are tall cells and there are short cells, epithelial cells. Okay, so why are they appearing as falsely layered? Because the nuclei is present at different levels. It is present at different levels. Okay, then it is called as a falsely layered epithelium or pseudo stratified epithelium. Out of this, the tall cells are ciliated. Out of this, the tall cells are ciliated. They have cilia on its surface. Short cells are non-ciliated. Short cells are non-ciliated. Okay, this is what is called as a pseudo-stratified epithelium. Pseudo-stratified epithelium examples are male urethra. Okay, you can remember just one example. The male urethra is internally lined by the pseudo-stratified epithelium. It is internally lined by the pseudo-stratified epithelium. Okay, this was about the simple epithelium. Moving next to the compound epithelium. Moving next to the compound epithelium. What is compound epithelium? The compound epithelium is nothing but it is having several layers of cells. It is made up of multiple layers of cells. Okay, yes, let me draw this. It is having multiple layers of cells. Okay, Now, this compound epithelium can be again further classified. It can be again further classified. Compound epithelium can be classified on the basis of on the basis of on the basis of elasticity, on the basis of elasticity. Elasticity is nothing but stretching capacity. Elasticity is nothing but stretching capacity. On the basis of elasticity, they can be classified into stratified compound epithelium, stratified epithelium, okay, and transitional epithelium, and transitional epithelium. Okay, so stratified epithelium are nothing but they are multi-layered. Stratified means already multi-layered. They are multi-layered and do not have stretching capacity, do not have stretching capacity, non-stretchable. Okay, next one is it has stretching capacity, or you can directly write it is stretchable, stretchable with high elasticity, with high elasticity. Okay, these are the two types of compound epithelium. Now, as I told you that stratified epithelium is multiple layered. Now, on the basis of what is the shape of the cells in the topmost layer, what is the shape of the cells in the topmost layer, stratified epithelium can be further classified into three types: stratified squamous, stratified squamous, okay, stratified cuboidal, stratified cuboidal, and stratified columnar, stratified columnar. Okay, if the topmost layer of cells is squamous, if top layer is having squamous cells, then it is called as stratified squamous. If the top layer is having cube-like cells, cube-like cells, then it is called as stratified cuboidal. If the top layer, if the top layer is having tall slender cells, tall slender cells, then it is called as stratified columnar, then it is called as stratified columnar. Okay, now again squamous cells on the basis of, on the basis of whether, I'll write over here, on the basis of keratin production, on the basis of keratin production. Okay, can be further classified as stratified, or you can, I'll not write extended form, I will write non-keratinized, non-keratinized and keratinized. If they are producing keratin, keratinized. If they are not producing the protein keratin, non-keratinized. Okay, non-keratinized is present in non-keratinized is present in vagina and cervix. I'm giving you few examples, okay? Whereas keratinized is present in nails, okay? Nails, feathers, etc. They are having the keratinized squamous epithelium. They are having the keratinized squamous epithelium. Okay. Next one, stratified cuboidal. There are no further classifications. Rather, the example for stratified cuboidal is buccal and pharynx. Pharynx. Okay, the buccal cavity and the pharynx is internally lined by stratified cuboidal epithelium. Next one, again we are having stratified columnar on the basis of on the basis of on the basis of cilia, whether they are having cilia or not, whether they are having cilia or not. They can be further classified into ciliated, stratified ciliated columnar, stratified non-ciliated columnar, stratified ciliated columnar and stratified non-ciliated columnar. Okay, so this is what about the stratified epithelium. Okay, see dear, you learn it in the form of a flow chart, then examples will be much easier. For now, you are not supposed to remember many examples, just few of them. How does it exist is more than enough. When you will be learning the chapter structural organization in animals, then it will become much clear for you people. Then it will become much clear for you people. Okay, coming next to the transitional epithelium, I don't want to change it. Transitional epithelium, nothing more, which is having stretching capacity, is called as the multiple layered of cell, which is having stretching capacity is called as transitional epithelium. I am going to write the examples here itself. Urinary bladder, urinary bladder and ureter. Okay, both of them are internally lined by transitional epithelium. Your urinary bladder is having a certain capacity to hold the urine, right? But suppose in case of you're holding your urine because of not availability of washrooms or so. So what happens is urinary bladder extends its capacity. It keeps on, it stretches to increase the capacity of holding the urine. Understood? But holding urine for a longer period of time also is not good, because it will cause the infection in the urinary bladder. So urinary bladder is internally lined by transitional epithelium, which allows the stretching capacity of the transition of the urinary bladder. Okay, so this is about the epithelial tissue. Is the epithelial tissue clear? I have no responses from you people. Are you people there? Attentive, not attentive? Yes. May I know you're listening or not? I have just introduced you the terms. That's it. Nothing more than that. Okay. And the terms are easier to understand with the names itself. Stratified means multiple layers. Transitional do mean multiple layered, but it is having stretching capacity, whereas Stratified is not having the stretching capacity. Okay, so this is about the epithelial tissue. With this, we have actually completed epithelial tissue, and we'll be now moving on to the next type of tissue, that is connective tissue. Okay, now coming on to connective tissue, what is exactly connective tissue? The name itself is telling that it is connecting the different parts of the body. Understood? Okay, now that is the simple terms. Now I will give you the scientific term. The most abundant and widely distributed type of tissue in our body is connective tissue. Let us note it down. Most abundant and widely spread tissue. Okay, it is the most abundant and widely spread tissue. This connective tissue is making about 30 percentage weight of the body. 30 percentage weight of the body. Okay, so 30 percentage of weight of the body is because of the connective tissue. It is because of the connective tissue. Okay, it is the most abundant and widely spread tissue. It helps in connecting connecting softer tissues in the inside, in the internal part. Okay, softer tissues and organs. It helps in connecting the softer tissues and organs in our body. Okay, now how does it actually connect? It produces, or you can say, all the connective tissue, all the connective tissue except fluid connective tissue, except fluid connective tissue produce fibers. Okay, what are those fibers? Those fibers are collagen and elastin fibers. Okay, so it is actually helpful for connecting. It is actually helpful for connecting. But all the types of connective tissue, they are producing certain fiber like structures which are collagen and elastin fiber. But out of different types of connective tissue, the fluid connective tissue does not produce any kind of fibers. Okay, now there is supposed to be a matrix between them. It has, or it also produces certain modified polysaccharides, certain modified polysaccharides which act as ground substance, which act as which act as ground substance or matrix between the fibers, or matrix between the fibers. Okay, so what are we having? We are having the ground substance. What is this ground substance? Nothing but the modified polysaccharides. Nothing but the modified polysaccharides is being produced, which is occupying the space between these collagen and elastin fibers, which is acting as a ground substance or matrix, which is acting as the ground substance or matrix. This is the basic introduction of the connective tissue. So what do we know? It is the most abundantly and widely spread tissue. It is connecting and supporting the softer organs. It is occupying 30% of the weight of our body. All the types of connective tissue except the fluid connective tissue is producing collagen and elastin fibers. There are certain modified polysaccharides which are produced in between this collagen and elastin fibers, which are acting as the ground substance, or we can say it is acting as a matrix. Okay, and one more important point is connective tissue helps in wear and tear function in our body. This is very important. Okay, so connective tissue is helpful for wearing and tearing function. Matlab somewhere it is helpful for the repairing function as well. Wear and tear function of our body is carried out by the connective tissue. This is the basic introduction about the connective tissue. Now we know what is connective tissue. Moving on to the next types of connective tissue. Types of connective tissue. Okay, now when I'm talking about the types of connective tissue, they are of two types. They are of two types. What are the two types? The two types are connective tissue proper, connective tissue proper. I'm first drawing the entire flow chart because there are many types. So I'm drawing the entire flow chart, then we'll be going one by one. Okay, connective tissue proper and specialized connective tissue and specialized connective tissue. Okay, next, this connective tissue proper is further classified. It is further classified on the basis of the arrangement of the cell fibers into loose connective tissue, loose connective tissue, and dense connective tissue, loose connective tissue and dense connective tissue. Okay, on the basis of cell fiber arrangement, on the basis of cell fiber, I think I should be writing it in the opposite side. On the basis of cell fiber arrangement. Okay, next, this loose connective tissue can be further classified into three categories. can be further classified into three categories. They are areolar tissue, adipose tissue, and reticular tissue. And reticular tissue. Whereas dense connective tissue can be further classified into dense regular and dense irregular tissue. Dense regular and dense irregular tissue. This specialized connective tissue is further classified into two types. Number one, skeletal tissue. Number two, fluid connective tissue. Okay, skeletal tissue can be further classified into two types. One is bone, second one is cartilage. Second one is cartilage. Fluid connective tissue can be further classified into two types: blood and lymph. Blood and lymph. This is the flow chart for the types of connective tissue. Okay, so types of connective tissue proper, and then we are having connective tissue, specialized connective tissue. Okay, connective tissue proper can be further classified into loose connective tissue on how the cell fibers are arranged, into loose connective tissue and dense connective tissue. Loose connective tissue can be further classified into areolar, adipose and reticular tissue. Dense connective tissue is further classified into dense regular and dense irregular. Dense regular and dense irregular. Specialized connective tissue में two types are there. One is skeletal tissue and the other one is fluid connective tissue. Skeletal is bone and cartilage. Fluid connective tissue is blood and lymph. And as I mentioned earlier, that all the types of connective tissue except the fluid connective tissue, if I remove this, except the fluid connective tissue, is having the capacity of secreting collagen and elastin fibers. Fluid connective tissue mein, just imagine if the blood will be producing certain collagen and elastin fibers, how is it supposed to flow? It will not flow. That is the reason why fluid connective tissue is not producing any sort of collagen and elastin fibers. Is this flow chart clear? Yes, is this flow chart clear? Yes or no? Today, you people are either not active or you people are sleeping. One of them. Yes. Are you people active? Yes. You don't want the class? Okay. Fine. So now we will be learning about each one of them. We'll be learning about each one of them. So first one, as I said, it is nothing but connective tissue proper. Connective tissue proper. Connective tissue proper is further classified into, it is further classified into two categories. What were the two categories, Tana? Loose connective tissue, loose connective tissue and dense connective tissue. Loose connective tissue and dense connective tissue. Okay, this loose connective tissue may, what are the points we are supposed to remember? Cell fibers are loosely arranged. Cell fibers are loosely arranged in the ground substance, in the ground substance. Okay, or you can say the matrix. Here in dense connective tissue, from names only we can learn most of it. In dense connective tissue, cell fibers are compactly and tightly arranged in the matrix. Tightly arranged in the matrix. Okay, what is mean by connective tissue? Bushra, after me explaining everything, connective tissue which connects the softer organs. When I'll be telling you the examples, now it will become much clear for you people. Now see, bone is connecting the organs, the cartilage is connecting the organs, blood, lymph is connecting the organs. These, the connective tissue proper is only a little bit new to you people. Remaining all you already know. Understood? It is matrix, nothing but the medium in which we are having the cell fibers, which are either collagen fibers or elastin fibers. Got it, Pranavi? Yeah. Now coming again back to loose connective tissue. Loose connective tissue, it is further divided into how many types? It is further divided into three types. What are the three types? The first one is areolar tissue. The second one is adipose tissue. Okay, adipose tissue. And the last one is reticular tissue. I'm writing only T, reticular tissue. Okay, now we will be writing about the points in it. Areolar tissue is present beneath the skin. It is present beneath the skin. Adipose tissue is also present beneath the skin, under the skin, okay? Beneath the skin. Understood? Next, what is the function of areolar tissue? It has, okay, what is the function? It is a packaging tissue. It is a packaging tissue. When I write T dot, it means tissue, okay? Adipose tissue, whatever, when you are taking in food, okay, it is converted into energy. The unused glucose is stored as fats. It is stored as fats under the skin in adipose tissue. It is stored as fats under the skin in adipose tissue. Reticular tissue is supporting framework. Supporting framework. Okay, here in areolar tissue, it has air-filled spaces. Air-filled space, which are called as areolae, which are called as areolae. Okay, this air filled spaces, because areolae are present, it is called as the areolar tissue. It is called as the areolar tissue. Next, adipose tissue is of two types. It is of two types. Okay, what are the two types? Brown adipose tissue, that is BAT, and white adipose tissue. And white adipose tissue. Brown adipose tissue is present in infants, whereas white adipose tissue is present in adults. Whereas white adipose tissue is present in adults. Next, reticular tissue is present in bone marrow, spleen. Okay, two are enough. Bone marrow and spleen, they are having specialized reticular fibers. They are nothing but the modified they are having modified reticular fibers. They are having modified reticular fibers. Okay, is it clear? Now I will be showing you the diagram of adipose tissue. This diagram is actually there in your NCRT, which is a very, very important diagram. Why is it important? Because questions are coming. They give this diagram, they ask you to label the diagram. Okay, and remembering the functions of each one of the part as well. Okay, so areolar tissue internally looks like this. What does it have? Let me label the parts for you people. Okay, this is a fibroblast. This is a fibroblast. Okay, which is producing collagen fibers. Which is producing collagen fibers. Okay, then we have mast cell. This is a mast cell. I'll be telling you the functions, don't worry. These blue colored fibers are reticular fibers. They are reticular fibers. Okay, and this is nothing but a macrophage. This is nothing but a macrophage. Okay, so coming to its functions, fibroblast produce fibers. Okay, fibroblast, if you see this here, this white colored part is the fibroblast, which is producing the fibers, which is producing the, okay, I'm sorry, this is areolar. Yeah, just a mistake. This is areolar tissue. Yeah, thank you. I meant areolar. Okay. Yes. Now, if you see that fibroblast is producing the collagen fibers. Okay, so collagen fibers are produced by fibroblast. Produced by fibroblast. Okay, then we have reticular fibers, which is providing the framework. Then we have mast cells, which secrete inflammatory substances, Okay, what are these inflammatory substances which we have already learnt? That is nothing but histamine, serotonin, heparin, and there is another one which is bradykinin. These are the inflammatory substances which are produced by the mast cells. So, point to be remembered, inflammatory substances were earlier we studied in blood that it is produced by the basophils. So, basophils and mast cells, both of them are producing these inflammatory substances. Then we have macrophages, which is responsible for phagocytosis, Okay, and this is the ground substance. Which is also called as the matrix. Okay, so this is how exactly the areolar tissue looks like. So areolar tissue is present in nothing but the beneath the skin, which is responsible for the packaging. Okay, this is about areolar tissue. Now I talk about the adipose tissue. Okay, how does adipose tissue look like? As I already discussed, that it is present beneath the skin. And it is having large globular cells like this. Okay, so it has large cells which are called as adipocytes, So what does adipocytes do? Adipocytes store the unused glucose is stored in the form of fat under the skin. It is stored in the form of fat under the skin. This is what is called as the function of the adipose tissue. And as I mentioned earlier, it is of two types: brown adipose tissue and white adipose tissue. Brown adipose tissue and white adipose tissue. I'll give you a little information about both of them. Brown adipose tissue is present in infants. It has large lipid globule. It has large lipid globule, more mitochondria, is present in case of brown adipose tissue, whereas white adipose tissue is present in adults. It is present in adults. It has small lipid globule, small lipid globule is there, and it is having less mitochondria, due to which the energy is less. The energy is less. Okay, so this is about the brown adipose tissue and white adipose tissue. These are the two types of adipose tissue. Is it clear? Is it clear, Nana? Yes. Okay. Next one is the reticular tissue. I think reticular tissue, we can write it over here. This is already given. Na? Reticular tissue is the supporting framework which is actually present in bone and the spleen. But brown adipose tissue, Nana. Brown adipose tissue. Because I said no, it is of two types. Brown adipose tissue, white adipose tissue. Is it clear? The brown colored is because of a pigment called as cytochrome, which is usually present in infants, That is the reason why they are producing more energy when compared to the adults. They are having usually more energy when compared to the adults. Is it clear? Yes, is it clear? Okay, connective tissue, I will draw the diagram of this over here. Matlab, how does it actually looks like? It is having many reticular fibers. Okay. Okay, it looks like this. It is having many reticular fibers, which is acting as a supporting framework, This is how a reticular tissue looks like. These are reticular fibers. Reticular itself means mesh-like or network-like. Specialized cells in form of network. Nana, is it clear? Yes? Yes or no? Okay, I think enough for the day, because dense connective tissue and the remaining we will be learning it in the next class. Or shall I complete dense so that we can start with the specialized connective tissue in the next class? Shall I complete dense connective tissue? That will be better. Yeah. Dense, very simple actually. That's why I started. Dense connective tissue. Okay, what does dense connective tissue mean? That it is having a very compactly arranged cell fibers. Densely arranged cell fibers are there. Dense connective tissue is of two types, as I mentioned earlier. It is dense regular and it is dense irregular. Dense regular and dense irregular. Okay, dense regular means cell fibers are compactly arranged in parallel fashion, are compactly arranged in parallel fashion, which means they are arranged parallelly. Okay, whereas dense irregular cells are compactly arranged, cells are compactly arranged in random fashion. They are not present in a regular arrangement. Okay, do you people know about tendon and ligament? Have you people been told about tendon and ligament? I missed cell junction. Okay, cell junction we'll learn in the next class. Okay, my hair, cell junction we'll learn in the next class. Okay, yes. Tell me tendon and ligament whether it is dense regular or dense irregular. Tendon and ligament whether it is dense regular or dense irregular. Anyone? Samhita? Tendon and ligament is dense. Some are saying regular, some are saying irregular. Tell me. It's dense regular. Okay. Dense what? Samhita, you did not answer me. It's dense regular. Okay. So if I show you the diagram of this, dense regular, as I told you, it is like the cell fibers are arranged in a parallel fashion like this. Array. Yeah. Okay. Whereas dense irregular may the cell fibers are not arranged in a parallel fashion. Rather, they are arranged in an random fashion. Rather, they are arranged in a random fashion. Okay, that is what is dense regular and dense irregular. Last topic of the day, dense regular is further divided into two types, tendon and ligament. Tendon and ligament. Okay, tendon is nothing but it connects skeletal muscle to bone. It connects skeletal muscle to bone, whereas ligament connects bone to bone. Connects bone to bone. One of your bone is attached to the next bone with the help of ligament, whereas skeletal muscle is attached to the bone with the help of tendon. With the help of tendon. I hope it is clear. I hope today's class is clear. Yes. And I have a good news for you that you people are having a holiday tomorrow. Tomorrow there will be no classes. Okay? It's a holiday for you people on account of Bakrid. Okay? Yeah. I hope this class was clear. This notes will be shared and I want you people to copy the notes wherever you are not. See, these are nothing but the new terms which you must have heard or you must have not heard as well. Okay, already you had CBC classes, so you must be into it. Okay, so I want you people to copy the notes. Let the notes be up to date. We'll be again meeting back in the next class, that is day after tomorrow. Is it clear? Most probably the classes will be till 30th. Most probably. I'm saying most probably it will be till 30th. Akshaya, I know, yes, but it is lack of time. Okay, but yes, by the time I will tell you, by the time the notes is shared. So, Yeah. By the time the notes is being shared into the group, let me tell you the facts of the day. The facts are nothing but that I already discussed in the last but not the last to last class, that what is the scientific reason for bangles, nose rings, earrings, anklets, toe rings, chain, etc. Right? So there is a scientific reason behind everything. First of all, I'll tell you about bindi also. The bindi that we put in the middle of the eyebrows, that is at the forehead. If you people know naturopathy, okay, if you people know naturopathy, this will be shared in the group, Pranavi. This will be coming into your account now. Okay, let the PDF come. Yeah, talking about the bindi. If you know about yoga mein there are chakras in our body, right? And the first and primer chakra is this, which is present. Okay, so the energy from all over your body is usually getting accumulated in the region between your eyebrows. Okay, a bindi is usually for protecting that energy. It's not only that bindi should be there for only female. Even male, according to the Hindu tradition, male should also be putting a small kumkum or like chandan tilak. They should be putting. The reason, scientific reason, is the energy which is accumulated from all the body. The energy gets accumulated in the region between your four, that is the eyebrows. Okay, so that energy is supposed to be protected with the help of this bindi. That is about bindi. Next, coming to the earrings. Earrings may, we know again according to the yoga and naturopathy that there are different acupuncture points in our body. The one of the acupuncture point is your ear as well. Here, if there is a piercing done, then it helps in a proper and balanced energy of your body. The acupuncture point present over here helps in the proper balanced temperature, proper balanced energy of your body. Coming to the nose, usually nose piercing is the nose pin. The nose piercing is done on the left side of your nose. So if you again go to the Ayurveda or you study about the naturopathy, you will see that there is one acupuncture point which is present on the left nose. Okay, when a piercing is done on the left nose, it is majorly for the it is majorly related to the reproductive health of female. A female usually has a nose piercing, so this acupuncture point is connected to somewhere the reproductive organs of the female body. So this is nose pin regulates the reproductive health of the female. Next, coming to the chain. We are having many nerves of our body which are present in the chain. If you know karate and all, then you will see that there is a main nerve, the blood flow. It is occurring through the artery, it is flowing through into the brain. One shot over there and the person dies. What is all of this? Majority of the nerves are being accumulated in your neck region. So this chain is regulating the temperature. Okay, because there is major blood flow over here, so the circulation of blood and the temperature and the energy of your body is again conserved by this chain. It could be a gold chain, it could be a silver chain. Usually metals draw the energy. Metals draw the energy, they are extracting the energy. That is why a chain. Next, coming to the bangles. Bangles, there is a continuous, when we are moving hand, there is a continuous friction between the bangle and your skin. Okay, which is again helpful for regulating the energy, because we have nerves over here as well, right? And the body temperature and the energy of a female body is being regulated by these bangles. It is being regulated by these bangles. Actually, when you are moving hand, the friction which is produced between, it is majorly when it is a metal bangle. Okay, I told you, no, metals are drawing certain energy. That energy is conserved by this bangles. Okay, next, moving on to the anklets. Anklets and toe rings, both of them are having a similar reason. Toe rings and anklets, majorly they are made up of silver. Okay, silver draws the energy from the earth into your body. Same like bangles, the anklets also, when they are producing the friction with the skin of your ankle, then they are drawing the energy. They are making the circulation of the blood into your body. That is the reason for anklets. Coming to toe rings, which is made up of silver, toe rings are usually worn on the second toe, right? So here it is helpful for drawing the energy from the earth, number one. Second most important thing is it is associated with the reproductive health of the female. Okay, so usually after marriage only the toe rings are worn. Why? So that the female can have a proper reproductive health, such that there is no problem in the menstrual cycles, thus there is no problem in the childbirth as well. Okay, same is the case with finger ring, the wedding ring, which is usually worn on the ring finger of the left hand, right? Or you can say the ring finger of right hand. But why ring finger? Because there is a nerve. This you must have already seen in many Instagram posts and all. There is a nerve in this ring finger which is directly connected to the heart. That is the reason why wedding rings are worn on the ring finger. These are the various scientific reasons of the ornaments that we actually wear. According to this, why female is, the reason might come, ma'am, this scientific reason could be applicable for male as well, right? But why female? Why female? According to the tradition, earlier, if you see the early old stories of like Ramayana, Mahabharata, even male used to have ornaments, but later on it has started diminishing. But why female ornaments have become mandatory, or not mandatory, but why female should? We have a lot of energy inside our body. Okay, I'm talking about the, not the energy of the muscular energy. Okay, the emotional balance in female is supposed to be maintained. The internal energy is supposed to be maintained. Like you say, no, the kinetic energy, potential energy, I'm talking about that type of energy. I'm not talking about the muscular energy. Okay, so the internal energy has to be balanced, the body temperature has to be balanced. Okay, and there is also protection of a female body from the surrounding negative energy. These ornaments do protect the female body from the surrounding negative energy as well. These are the different scientific reasons for the ornaments that usually are being worn. Is it clear? Yes. Okay, champs, that's it for the day. The fact is done. The topic of the class is done. Next class, we will be moving to the next topic, that is nothing but the specialized connective tissue. Okay, I hope it was interesting. Okay, champs. Thank you. That's it for the day. Have a great day. And tomorrow is a holiday, as I told you. No classes. Okay, yes, the PDF is coming.